Hey, Michael.
Hello.
All right, we're going live.
Morning, Michael.
Hey, Tony.
Let me know when you've gone live, Tony.
Yep, it should be live now.
Well, wonderful. Good morning, everybody. Good afternoon and good evening to you there around the world. I'm Ken Tagami, joined with Tony
Michael.
and Michael Wilkinson.
Okay, let me.
If you've got your YouTube stream running, you might want to put it on mute. Awesome. So we've got a lot covered today. This is episode number 9. We started this
Number 9.
Number nine. There you go. A little audio there to some old school music for those of you that were around during that era.
My habit.
Actually, that wasn't their latest work, right? Was that the White Album? No.
That was the White Album.
What's the White Album? Okay,
Yep.
there you go.
Yep.
All right.
Revolution number 9.
Quest. Awesome. That was the Beatles, folks. To fill in the blanks there.
Yeah, both of you are looking a lot brighter today.
Oh, well, thank you. Maybe I got.
I think it's the 300 watts of plant light that I have in front of me.
Oh, there you go. And we were joined with Shivar from South Africa.
Hey, Shivar. Good to see you.
Yeah, great to see you.
Mm-hmm. And I guess we're going to expect to see more guests popping on as we move along through the day. So we're launching a high altitude balloon or mid altitude balloon, if we want to get technical, a long range balloon. Hey, here we go. Javier.
Javier.
In about an hour, we'll be launching that balloon from the Berkeley Marina. And we hope it goes a little farther than our balloon last week.
Did we ever figure out what happened last week?
I'm going to estimate it was pilot error. I'm gonna wave my hands here. And the way I secured the balloon to the instrument was improper because we're rising at pretty decent altitude. We're getting around 22,000, 23,000 feet or so.
Yeah.
And suddenly this precipitous drop, which tells me balloon burst and it's falling or it got disconnected. And this thing's fairly light, only weighs about 16 grams. I got it over here. I'll show you. And it just kind of fell out of the sky. Now it's somewhere between the Delta in North Bay and like Benicia. It might be in the Delta. But maybe if someone finds it, there's information on the back of the solar panel. They can give us a little shout out. That would be kind of cool.
Well, I thought it went down in a park.
It might have, but it was around 8,000 feet when we got the last blip. So it was still.
Oh, okay. So it could have drifted quite a ways on the.
We got to run a little math there.
Yeah.
Estimate wind speed and direction.
Right. How do the conditions look this morning?
What's that?
How do the conditions look this morning?
It's gorgeous today. I haven't stepped outside, but our weather's clear. I ran a flight prediction. We can talk about it a little bit, but what have we got in order for us today? Actually, our main focus is putting something in space. We've run 7 experiments now on the International Space Station in something called ExoLab. And we're getting planned for experiment number 8. And experiment number 8 is going to be doing some investigation that we're going to need your help with. And this is the fun part. We're calling it the Leguminaut Challenge. And so the first part of our hour here, or our 4 hours, the first hour or so, we're going to talk about what it actually is and how you can get started. It's free. There's no cost to help us during the first phase of this program. But if you want to join us on the flight, there will be a little bit of money to help subsidize that rocket ride up to the space station, our on-orbit activities, and of course, when we bring it back home again to do some science here on Earth. But you're welcome to join us along the ride as far as you can go. It's a lot of fun. There's really some cool folks from around the world. And already, where did some of our colleagues popped off? They disappeared.
Yeah, I don't know what happened.
Uh-oh.
Yeah, we had South Africa and Mexico on the line. Did we just lose the Southern Hemisphere?
Uh-oh. Is the planet really flat?
The cat's pushed him off the edge.
There you go. Keep track. I guess what we've done now is you've got those waiting rooms and Zooms.
Yeah.
The waiting room might be acting intermittent here today or something, but we'll keep an eye on the waiting room, make sure we're not missing everyone. Usually we have quite a number of teachers in. Steve was in earlier, Steve Jones out of Atlanta. I don't know, he disappeared too. So.
He said he's rebooting his computer.
Got it. All right, he'll join us shortly. So let me show since I mentioned it, I'll show you what the Sky Tracker looks like, the little Pico hab we're going to launch. but we're going to jump into what is Leguminaut Challenge and how you can get started. So hang on. All right. So I've actually already filled it up last night just to make things a little easier for us today. This is normally a program we do with the schools directly. Lodi Unified School District is our host for these balloon launches. Thanks to them, you guys get to enjoy in the ride. Hey, Renee.
Hey.
Steve.
Good morning.
Looks like Steve's back, the guy that loves lentils in a spider suit.
Absolutely. Good morning.
So
I got my Hubble earrings on, the 30th birthday of Hubble today.
oh,
Hey,
Oh,
happy birthday, Hubble. So we'll send up a little baby satellite in commemoration of that. This is our second launch on Magnitude Live and the third launch for Lodi Unified School District this season. Normally, we work through a program about 1 week long where the students study the atmosphere. They learn about the troposphere and the transitional layer called the tropopause, and then moving kind of into the stratosphere. This balloon really doesn't get up at that altitude. We have some other high altitude balloons that'll take us up to around 100,000 feet. But this little guy is on solar power, as you saw. It runs a little ham radio, an amateur radio on an APRS system. It's a packet radio system for tracking. It looks like we got more of our guests joining in. Awesome, including Sam. Hey, Sam. Sam is our host teacher here, and Diana might join us as well from Lodi. And so that's what our little device looks like. And of course, what I'm flying this thing on is, oh, look at that. It's just a Mylar party balloon. That's it. But we're going to get up around, well, let's hope we get up there this time, 25 to 30,000 feet. And this is looking like it's supposed to travel across the central part of the United States down toward the south. It might be even flying right over you, Steve, or maybe even around you, Javier, in Houston on the way to the Atlantic. So I can
something with it.
What's that?
Send me something with it.
Well, we'll see what happens with that. But so that's what's coming up here in about 45 minutes or so. But now I'm going to jump into like our main attraction. Just a quick round robin to see who's joining us. We've got Michael Wilkinson here from Magnitude out in New York. Tony's with us in Berkeley, I guess Oakland, since he's stay at home. Javier in Houston. Steve's in Atlanta. Renee's in Rhode Island. And we've got our friend from Canada. Hey, Dana.
Bonjour, hello.
Bonjour, ça va?
Here from South Africa, and Samantha from Lodi.
and we have Sarah Grow from Hungary on YouTube.
Oh, wow.
Fantastic.
Wow.
Hello, Hungary. And I guess we'll have others joining us as well. So on the YouTube channel, feel free to ask some questions. If you like what you're seeing back here, you want to join us, send us a note, hello@Magnitude.io. We run, I think we've got 5 more sessions after today. We run these usually in a large block. We have guests that pop in, share some of their stories and experiences as we think about what we're going to put in space. And so that little balloon is an interesting diversion. We're building up to an actually a hope that we can take one of these payloads, different type of balloon, and circumnavigate the entire planet. We'll be trying that probably in about a month. We're ordering up the balloon and we're looking at how to do that right. And we have been asked to participate in a challenge with our friends in Southern California, and they want to launch a long distance balloon as well at the same time on June 1st. So mark your calendars. We'll see if we can't get around the world with some
Hey,
balloons.
Ted, can we get some clover on that?
You know what? I can probably, they're small enough seeds that I can probably do it and then adjust the weight a little bit. The thing is, you know, these were designed by Bill Brown out of Huntsville, Alabama, as a NASA engineer, and he's very, very exacting. In fact, each one of his balloons or his sky trackers, he gives us a little card here with the actual mass in grams to 2 decimal places, as well as the weight of the line and the tape and the total weight and the amount of free lift we're going to need to do to calculate to get that thing at the distance, at the altitude that we desire. So thank you to science and to Bill for
I think the clover seeds would be perfect ballast.
Yep. Well, I'll just put one little extra squirt.
Nice try, Mike.
Wonderful. All right, so let me jump over to really our star of the show. It's something called ExoLab. And ExoLab is an opportunity for schools around the world to connect to the International Space Station and run alongside a live experiment. And we're in phase 1, and there's no cost for phase 1. If you want to join us on the ride to space, we're going to ask for a little bit of help. This is subsidize that cost, but we distribute across hundreds of schools, so it's relatively inexpensive. So instead of tens of thousands of dollars, we're looking about the equivalent of about $500 if you have an ExoLab to get it up there. With the ExoLab, it's about $900. But you can use that ExoLab for missions. Sam has joined us all the way since mission 1 back in 2017.
Yeah.
And she's
Hello,
been
Sam.
7 flights, I think, with us, ready for mission 8 here in February. So I'm going to share my my screen here and walk through a brief on what we're doing, what ExoLab is, and kind of our main objective. And Javier is here from Houston, and he's going to do help us with some translation in Espanol. I think you guys can see my screen now. Y'all see that?
Yes.
Great. All right. So I think this is pretty important. We talk about the future. We talk about what's going on. And, you know, it's here already. We've got brain organoids that are being grown in microgravity on the space station. We have artificial intelligence and machine learning that's being worked on right now. We have cars that are trying to be self-driving and electric airplanes. You know, it's really a pretty amazing world that we live in. We've got the world's information that we can put in our pocket and walk around and get whatever knowledge we might want if we know how to ask the right question. But it's here, but it's just not evenly distributed. And as we think about all of us being around the world, being stuck at home, we can consider it stuck, but really, I think it's an opportunity for us having to stay at home because of a pandemic. Something affects the entire planet and not just the wealthy, not just the poor, but really everybody. Here from Earth, from the International Space Station, there are no borders. There are no countries. There are no counties. There's just blue ocean and there's land. And on that land, you can see deserts and forests and just you know, fields aplenty. You can see the animals through migration if you're focused on that. It's absolutely an amazing world that we live on. And so, what can we do to create kind of a little more equity? Is really kind of our focus. The space station is really our research platform, and we're very thankful for the U.S. National Laboratory on the space station. Without their help, we would not be able to run this research for students in the United States and welcoming students from around the world to do this. And it's massive. It's celebrating its 20th anniversary this year. And Renee there in Rhode Island just shouted out as we started the call that it's the 30th anniversary of Hubble, the space telescope. So happy birthday, Hubble. I think the space station's birthday is going to come up a little later this year, but it's massive. It's huge, 450 tons. And it's traveling extraordinarily quickly. It'll travel around the Earth in 90 minutes while we're talking. In fact, on the screen behind me here is something called ISS Above. It's a little Raspberry Pi computer that connects to a live stream from the International Space Station. So that's Earth right now as it's over New Brunswick, Canada. How about that? And by the time the show's over, it would have gone around the Earth probably 2.5, maybe 3 times. It's, you know, as I mentioned, been up there about 20 years, but more than 230 people have been aboard. 18 different countries helped construct this and continue to add new assets to it. More than 2,400, probably closer to 2,500 experiments now have run on this thing, and more than 100 countries have participated. It's an amazing platform for research. And for all of you guys that are in school, for you teachers out there, every one of your students has only known a world that had the space station in orbit. If we think about that, it's pretty amazing. The National Laboratory I mentioned, without them, we would not be getting anywhere close to getting this stuff going. It's funded by NASA through Congress, and it's actually has the half of the astronaut time it can allocate and half of what we send up there, half of the up mass. And so if you have research, if you're in education, if you have a scientific breakthrough or even a potential technology you think can benefit life here on Earth, the National Laboratory wants to hear from you, whether you're university student, whether you're a researcher in a medical field or a material science or what have you. Even if you're a student, there are many opportunities up there. Magnitude and what we're doing with ExoLab is just one of many. And there's cool things like, you can have an astronaut read a story to you, or you can actually even talk to the astronauts through ARIS, the amateur radio on the space station. So lots of cool stuff to check out. But what is ExoLab? ExoLab, I got one here, actually, I'll disconnect. I have it running for my little plant experiment, is an Internet of Things device. And this is what it looks like. I've taken there's a plastic cover that goes on top of this that you can see through with a nice little measuring caliber on the side. But it has carbon dioxide sensor, so we can measure the CO2 levels that are happening ambient in the environment that it's in, temperature and humidity sensor, a light sensor, so we can see what kind of light we've decided to illuminate our experiment with. And that's wavelength. We can change the wavelength of light, the intensity, how much light we want to put on our experiment, and even the duration, the photo period. Do I want it running 24 hours a day? Do I want it run 4 hours a day? And typically what our classrooms do in our libraries is they set it to be equivalent to the mother experiment that we send up. So while we're running these experiments here on Earth, all around the world, across the different cities in the United States and different parts, we have this mother experiment that's running on orbit. And the experiments look just kind of like this. There are these aluminum boxes. This is a small one. It's a 10-centimeter cube. And if you think about the ExoLab, you can see that it's basically 2 of these, or 2U equivalent. And what's super cool about this, it's like intermodal transportation for space. So instead of that 40-foot container you might see on the back of a truck on the highway, or on a rail car, or on a ship going into port, this is intermodal transportation for space. And satellites are built with the same volume. This would be the smallest satellite you might see up there. There's some smaller ones, but we'll get into that maybe later. But this is a building block. Think about it like Legos. You can have a 2U or a 3U. A company called Planet.com, has a 3U equivalent. So it's about this size. The satellite is really just that large. And this would be all your avionics and controls for power and communications, what have you. And this rest, the 2U there, would be optics, basically just staring down at Earth, taking images with meters of resolution, super tight resolution. And they've got dozens, if not even 100+ satellites in orbit, rostering the planet, taking imaging as they travel around the world. And so they can look at forest fires, they can look at migration of animals, the human impact. They can count cars in a Walmart parking lot. They can do a lot of cool things. And there are a lot of different satellites built on this technology. What we've done is we've decided to run this laboratory, which can normally be very expensive, and then open it up for students around the world that want to join in that investigation. And as I mentioned, we're getting ready for number 8, and this is when we need your help. We're calling it Leguminaut Challenge. And there are 2 principal things that we're concerned with. There are many issues, but we're looking at the United Nations Sustainable Development Goals. Equity is a super important one. In fact, I should probably add that to our primary mission. And we think about that every day. We just want to make sure that everyone has a fair shake at an opportunity here on the planet. But 2 we're very focused on: zero hunger. There shouldn't be anywhere in the world where someone's suffering from a lack of food. Yet UN says essentially 22% of the world doesn't have a proper meal. And that is extraordinary to me. We got to change that. And I think our students around the world can help us in that. Another initiative that the UN is focused on, and as Magnitude and our team is quality education. If you look at the UN's premise around that, it's around physical location, like bricks and mortar, making sure there's power to a school and there's internet connection. But I think the pandemic's kind of sharing a little bit more with us. It's revealing that there's inequities in education, and we have to deal with distance learning. So how do we create those equities? How can we ensure that all students get an opportunity to see these experiences? But the Leguminaut Challenge, let's look inside the ExoLab and the higher level concepts, what it is that we're actually doing. We're trying to find a food or foods that can help us feed our populations here on Earth. But also, here's the fun part: if you're going to put something like a settlement on the moon, or you want to put something on the surface of Mars and have people inhabit it, well, what are you going to grow, right? What are you going to put in there that's going to be sustainable? You can't bring all your food with you, and your supply ship is going to come once every 6 months or so. So that's going to be kind of a chore, having to squeeze your breakfast out of a tube and your lunch out of a tube and your dinner out of a tube is not much fun. If you can grow your own food, well, that's kind of good. So what can we do there? We think legumes have a really good potential to be one of our primary candidates for food for the world and here on Earth, and but also for other worlds, whether we're on the surface of our moon or maybe on Mars or somewhere else. Nutrition density is one of our considerations. How much carbohydrates, proteins, amino acids, vitamins are in our plant that we can consume and can help us thrive. We might need some different types of vitamins if we have a deficit from the lack of sunlight there on the surface of Mars. So we need to take that in consideration. So what would be the best legume to grow? Is it drought tolerant? On Mars, it's pretty dry. On the moon, there's very little water. There's water ice. But here on Earth, there are places around our planet that don't get enough water. And with a global warming, with a change in our climate, we're going to see drought tolerance to being a much larger issue. Salt in our water can destroy crops and or have them just not even grow or grow very poorly. So can we find and develop and breed plants that have these capabilities to survive in brackish water? And one interesting quality about legumes is they actually form an interesting bond with bacteria. The symbiosis enables a bacteria called Rhizobia to collaborate with our legumes and actually produce excess nitrogen. The nitrogen is actually coming from Rhizobia. We'll hear more from our teachers on this throughout the rest of the program today. But through this dance of exchange of nitrogen from the Rhizobia and the sugars coming through the photosynthesis process through the legume, we have an excess of nitrogen in the soil. This is essentially a green fertilizer, helps it nice, rich soil, allows us not to deal with fertilizer that's artificial. It's kind of hard to bring a bunch of fertilizer to you to another planet. So you're going to have to kind of make your own. How do you create a proto soil? So you'll hear from some of our teachers that are actually working with simulated regolith, what we think the composition of the rock is on the surface of Mars and on the moon in different locations. And maybe, just maybe, we can think about what that might look like. Here's what an experiment looks like in space. It's a time lapse. This was a microgreens experiment. I think this was experiment number 5 out of the 7 that we've flown. And you can see different plants grow at different rates. Can't remember quite which one with this one. This might be, is that purslane? I don't know. But we had amaranth, purslane, wasabi, pak choi. Maybe that's pak choi. But you'll see this one is growing there in the second tube from the left. And then near the end of the experiment, these little guys, number 1 and 3, are kind of growing a little bit, but not much. Number 4 decides it wants to get in the action and starts growing. But these were early germination studies, and we're growing those in an agar medium. That's great for germination, but not great for full development of a plant. So we need your help, first of all, to determine what legume we'll want to fly. And there are a number of them. But we're only going to select one. And so that's our main goal of our challenge today. What I want to be able to do is share with you what's required to get started. It's really easy. Tony's going to walk us through our platform on how to register right now and what's required to get started. Super simple. We have Wednesday teleconferences, which you're welcome to join, in which we're just collaborating and talking about the experiments we've done so far. You'll hear from some of our teachers today on that. And also on these Fridays. So join us as we get experts from around the world, exogeologists and astrobotanists and astronauts. We had an astronaut join us before, and which is kind of nice. But we're looking at doing advanced research, engaging the students right at the very edge of discovery, right? Why wait? They can be in primary school and we can still get them excited. And of course, if you're in honors biology or AP physics or what have you, come aboard. We're going to challenge you with some really cool investigations. We want to find a way for everyone to get access. we found a way for this challenge to not even need to use a computer. Let's just grow something in our backyard or our side yard or in a window in a kitchen and help us to determine what we should be flying to space in February. And our big, I think, advantage here is we can leverage an asset, this extraordinary massive 450-ton device that's been constructed, probably the largest, well, it's definitely the largest thing in orbit, to benefit all of humanity. So what can we do? What can we do together, right? So that's kind of a super high level overview of ExoLab. I imagine there are many questions. If you have questions on YouTube, please jump in. And I talk too much, I'm going to open up just to our general folks here. Hello, everybody. If anyone else has popped in and said, I want to say hello.
There's a question.
Why don't
There's
we,
a question on YouTube.
yes, what do we got?
Alex, he is 7 years old from Hungary.
Awesome.
He's interested to know, how do you play chess in space?
Wow. So I guess if we keep with that two-dimensional board for right now, right? You're going to need to make sure those objects all stay in the same place. If you've ever gone on a long car trip, you might have the little magnetic chess pieces. So that might be a really interesting way. But if you use your engineer mind, you might think of a different way you might want to do that, right? How else might you keep something attached to a surface? So that's just keeping everything kind of like the way it is normal. But if you ever watch Star Trek, they have something called three-dimensional chess. So imagine if you had a cube that you were playing chess in, and you can move your pieces through space across 3 different axes, not just X and Y on a game board, but a third dimension. What might those rules look like? Could the bishop move from the top to the bottom? Could the queen still move anywhere she wanted? What would the horse do, right? The knight as it moved around. So that would be an interesting challenge to imagine what three-dimensional chess might look like, and would even be more complex, trying to keep all those pieces in the right place. But I don't know, some of my more expert fans of what happens on the space station, how do they play chess? Do you watch them playing chess up there? Has anyone seen that? Not yet? I bet they do though, right? Wouldn't it be cool to play chess with an astronaut in space while you're on the ground? You give them kind of like, queen's pawn to bishop 3 or whatever. I don't have to remember how to play chess. It's been quite some time. I play a game called Go, and it's an Asian board game, and very simple, 2 sides. You just place a single stone down, but I'll digress very quickly on that. But that's very interesting. How do you play chess in space? We'll try to find something for you maybe during the show here. Any other questions in YouTube there, Tony?
No, that was it.
All right. So why don't we try to keep to the meat of it? If you're joining us and maybe you've already signed up and you're trying to figure out how to get started with ExoLab and how to get started with our Leguminaut challenge, you don't need to worry about ExoLab for phase 1. But if you'd like to we're going to be moving into that phase where you'll be able to pre-order one for the fall back to school. But all you really need to bring to the table right now is your imagination and a little bit of work. Try to find some seeds somewhere. Hopefully there are legumes, because that's what we're trying to figure out. Which legume can we send to space? And we want you to grow those in your kitchen window, bedroom window, out there in the garden if you've got one, on your front porch, wherever you can, and see what life does here on Earth. And follow it along. We want you to be scientists here and observe and take record of the changing of the leaves, and as the height changes. Is it doing well? Is it getting enough water? Is it getting too much water or not enough? All these things we want you to kind of observe and record, and we want you to share your results with us. And Tony, can you walk us through just the super basics? How do you log in and get started with ExoLab?
Okay, super basic. All right.
So go ahead and share your screen and share it with us. And I'll just note that about 1/4 to the hour, I'm going to step away and get in my car and suit up, I guess, for being outdoors with my mask and all that. And I'm going to launch this high altitude balloon at the top of the hour. So, but for now, let's talk about ExoLab and the Leguminaut challenge.
Are you able to see my screen?
Yep.
Okay. So all you have to do is go to Magnitude.io. And right on the home page, you will see this one screen right here. You can either click to learn more, and it will take you to this landing page where you can see in more details of what the challenge is, what we are trying to accomplish, how we are trying to look for the right legume to use. So how do you sign up? All you have to do is click on this free sign up button. And you'll be taken to this page. Now, if you have a Gmail account with your school or personally, all you have to do is click on this button. It will ask you if you want to. You can choose the Gmail account that you already have. Now I'm using a email account that I have used already, and it will give me an error. But all you have to do is go through the three simple steps. Enter your district of your school that you are going to. For example, for me, I am already part of the USD, so I'm going to choose that. And I'm going to choose, okay, so I'm giving an error because I am, I have a account already. So I'm going to log on to my account. So this is your dashboard. Once you have this account set up, the first thing it will ask you to do is go take a look at all the free lessons in the lessons library. So these are all the lessons that we have set up for the challenge. And you can select in English, German, or Spanish. Yeah, if you are from a Spanish country, feel free to select one of these lessons to get started. Now, they are set up in a sequence that we would like you to get started with. Let me go back to the English. So you start with, from the top left to the right. So as far as setting up, this is it. It's really, really simple. And the other more important thing is that there's nothing for your student to do until you create a class for them to sign up. So all you have to do is create a classroom, give it a name. And I believe, yeah, just give it a name of the class, the period. You can have multiple classes. Once you have the classes set up, oh, I don't have this one set up yet. Okay. I'm going to create one. So once you have the class set up, and let's say you have 30 students, all you have to do is give them this URL right here and the class code right here. And they can create their own account to be in your class. So you don't have to import anything. You don't have to add the student to your class. If you want to, if you want to add the student one by one, you can do that right here. It's really, really easy. So once you have a class set up, now when the student log on to their account, there's nothing for them to do until you have a lessons assigned to them. So for example, like this one, all you have to do is assign this to your class. select your class. And I want them to get started tomorrow and get done by the 31st. And then that's it. So now when they log on to their own account, they will see their stuff. And that was it. Back to you, Ted.
Awesome. Well, I'm about ready to get in the car. So let's do this as I drive to launch this high altitude balloon. Let's share some of the investigations some of our teachers have already done. Let's talk a little bit about what we think about legumes and why we think they're important beyond that basic introduction that I gave. So I don't know, Steve, Diana, Renee, you guys want to chat about your favorite legume and why we think it's going to be something that's worth going to space about?
Sure, I'll start, but I'd also just like to go back to Tony. Tony, thank you so much for that. The wonderful thing that I had the experience of, and probably everybody else did, is that when I was getting this class set up, it looked a little complicated, but I realized it wasn't complicated afterwards. It's very user friendly. And Tony paid me the privilege of walking me through the steps. And those of us that are PIs, we're out here to support and do that as well. But it was really great to get that training, Tony, to be able to walk me through it and make it more comfortable as a teacher using it. And then again, being able to explain it to the children. You also came in and spoke to our group, Tony, and that too just made it more real for them. So those little additives are really, really, really key. So I really appreciate that. Just wanted to get that out there.
There you go. Want to give a little shout out in French too for us?
Oh God. Si vous avez une classe qui est évidemment très intéressant de participer dans ce programme, utiliser ce programme Magnitude.io. C'est incroyable pour les enfants, incroyable pour les professeurs. Vous n'avez pas besoin de beaucoup de choses pour ça. Simplement contactez Magnitude.0 et nous sommes allés travailler dans une classe incroyable, expérience fantastique.
Magnificent.
Okay, so now you guys translate that. All right. In terms of representing, there's so many great beans and bean experiences going on as we're growing in our home labs right now, which is really our kitchens and our dining rooms and everywhere else. But I represent Glycine Max. We are Team Glycine Max. C'est l'équipe Glycine Max. Glycine Max is the incredible soybean, which we believe has a great potential to return to the space station. When we talk about feeding astronauts and or potential candidates who are going to go to Moon and Mars, we are looking at the different beans, but we believe that Glycine Max has a great potential because it's been there before, survived, thrived, fed, and can do so many other different things. On our planet, there's over 50 different ways that we use the soybean, and they may be actually needed in the future on the ISS or perhaps on the Gateway or perhaps on the Moon or Mars. The incredible thing about this bean is that it is really, really quick to grow. Although some of the things that we're seeing right now with our bean samples, no, it's not going great. However, I will show you that we are also testing out organic biological black Glycine Max, and they are on fire right now in our lab. Opening up the lab the other day, we were surprised to see the sprouts and how well they were growing. Now they are being treated with the Rhizobia. So we're hoping for some really great results with those ones. So why do we want Glycine Max to go? Not only because Glycine Max is sort of the grandfather of being to the space station, but there's so much more potential for it. We want to feed those astronauts. We want to be able to make sure that they have sustainability there, and the transformability of Glycine Max is quite incredible. That's our pitch for today.
Awesome, Nana. Thank you. Steve, how about some lentils?
Lentils. Diana did a great job of, explaining kind of why we're studying legumes and what we're trying to do with this experiment. One thing with lentils, you mentioned soybeans being the granddaddy of the beans on the space station. Lentils were grown on Skylab back in the 70s. And so they were some of the first plants they did any experiments with gravitropism with to see if they could grow in the absence of gravity and how that affected them. But again, lentils are another bean that we're looking at. It's a very, very popular food item around the world. And actually Canada is the #1 producer in the world of lentils. I've been trying a couple different growth media with them. Here's one that I've been trying. This is about a 12-day-old plant. And this is currently growing in a 50-50 mixture of coffee and Martian regolith simulant. And I just spritz it with water twice a day, distilled water, and it sits in the kitchen window. So it's getting natural light just through the kitchen window. And it's good. It's growing slower than plants I've grown in, say, potting soil. But as we start looking at, moving away from Earth and trying to use materials that are on other planets or on the moon, we have to figure out what do we need to add to some of these, because there are no organic materials on those surfaces that we found yet. And that's what you need to help grow plants. So I thought, well, coffee is something that most astronauts and explorers are going to probably have with them. And you have to do something with those coffee grounds, and they are organic. So I mixed it in here with the regolith. Now I've tried just straight coffee in trying to grow plants and have not had good luck. Maybe that's because of how acidic coffee is. I'm not sure, but I could really use some help with some other folks who would like to try out some of those and test them as well. So that's my pitch for the lentil.
That's so
Well,
great.
thank you.
Steve.
I guess
Thank you.
the question I have is, what would Yuri eat?
What would Yuri eat?
I just want to throw in as well that we are using tea bags. I always forget to tell people that, and thanks for poking that in my brain, Steve. We started with tea bags a couple of months ago and putting plants inside of it when we were doing the cowpeas. Some good results, but COVID-19 throwing us out of our locations left the plants behind uncared for, and of course they did not thrive. However, we will be testing again with this round to see if we can get some growth in the tea bags. The other thing is you out to those teachers that are out there listening in. You heard Steve talk about you can grow it in anything pretty much, and that's what it's about. You don't have to have regolith right now. You can get peat moss. You can try any other substance that you want to test some growth in. So play with it, because that's what we're doing. We're really exploring, and it's a great inquiry for the students right now.
And one of the great things about these legumes that we've all been studying, and all of them, is they've been around basically running parallel with human history for thousands and thousands and thousands of years. And they're very, very hardy plants, which is why we're trying different types of media. They can grow just almost anywhere.
Wow, that was great. Hey, Javier, you want to translate all that in Spanish?
Ok, bueno, de lo que están hablando es de las plantas, estamos tratando los investigadores principales cómo crecer plantas en el espacio, pero necesitamos ayuda. Estamos tratando con diferentes semillas, diferentes legumbres, para ver cuál es el mejor medio de crecimiento. Un medio de crecimiento es un microecosistema en donde una semilla puede germinar. Necesitamos los nutrientes necesarios y la humedad necesaria para que las plantas puedan crecer. Aquí Aquí yo, por ejemplo, estoy tratando de crecer un poquito de lentejas. This is my small lentil. And with Steve. Son lentejas pequeñitas. El objetivo de nosotros es, como ellos mencionaban, estas legumbres han estado por nosotros durante muchos años. Son plantas que son muy resistentes. Por eso es el interés en nosotros en investigarlas y ver cuál es la mejor planta que se pueda mandar al espacio. Pero también necesitamos encontrar el mejor medio. Y como plantas resistentes, nosotros vamos a tratar de ver cuál es el mejor medio para que ellas puedan crecer. Got it.
That was awesome.
Cool, wonderful. All right, well, I'm getting close to finding a place where I can launch this. The weather is much better than it was last week for sure. Beautiful sunny day, very little wind. We should get a good lift and hopefully some distance. But we're joined, I know that Samantha McCoy has joined us from Lodi. And I'm not sure if we had another teacher or other students join us yet, Tony?
No, not on Zoom, except for Sam.
Okay, wonderful. And if any students are there from Lodi and watching, just give a little shout out there to Lodi in the YouTube chat, would you? It'd be great to hear that you've joined in and you're checking out what we're going to do. Sam, do you want to give us a little history about some of your experiences with, we usually do a much larger balloon with you, but Sam and her students at Christa McCullough Middle School, they're in the Central Valley in the San Joaquin County of California here, are planning to work with us, not just launching and following these smaller payloads, but we've got a balloon we're going to be getting here to probably launching near the end of May, maybe mid-May, and that we're going to try to do a circumnavigation with. Wow, actually go all the way around the world in these little balloons. But Sam, why don't you share a little bit about the experience your students have through designing our larger payloads and maybe some experiences that you've had in the classroom.
So good morning, everybody. My experience was a few years ago. None of my kids are with me anymore. So these current kids have not done the experiment with me. And I have to say, it's quite difficult to get kids on the distant learning thing. While we were going through this, I'm answering emails from my Space Center class of kids saying they can't get in, they don't know what to do. So that's my experience with distant learning. I'm having a really good time. I'm hoping that I can smooth it all out so that kids can get in and do this experiment with me. But right now, I'm not very successful. So I apologize for that. I did post up the link for YouTube for my kids, and I told them not right now. So I'm assuming they are not on right now.
I think Diana's students are coming on at 9.
So I should probably wait to launch. Maybe I'll just hang out in the car. I don't want to launch him without him. All right, Renee, alfalfa. Not that
Renee's
alfalfa.
on right now. I don't
Oh,
think.
she left? She's
Yeah,
got a class.
coming back.
She would be back.
All right. All right, so let's see. I think C might be on. Other things, how, what other kind of
Uh-oh. We can't hear you, Ted.
Tony? Am I on mute?
No.
Just a really bad connection down here at the marina, maybe.
Like we lost him there. Oh, there he is.
Can you hear me now?
Oh, much better.
All right. So great place to launch, maybe not great place for a signal on my phone. So where was my train of thought? Well, the Golden Gate Bridge is back straight away that way. And then we can actually see it today. Maybe not on my phone. But yeah, I've got a good signal. You guys can hear me?
Yep.
Okay, good. And when I'm in my car, I guess it gets dropped. I'll hang out here. So as long as I'm 6 feet away, I guess, from everybody. We really haven't talked too much about this symbiosis here, this relationship between the bacterium and the legumes. Legumes, of course, that's what we're going to eat. You know, does it have the right carbohydrates and the right proteins? What kind of amino acids does it have? The vitamins. What vitamins are we getting from our meal with our legumes? We actually have a guest coming on, or maybe a couple guests, at an hour from now. That will be talking about recipes and food. What can we eat? What's good? And I think they're going to join us every week and provide a little recipe, a little meal that we can make at home, especially with the limited supplies you might have in our kitchens. And not like go out and get some exotic thing to add to a meal. It's real simple, but tasty stuff. So that's something to look forward to. But this relationship between the legumes and Rhizobia is really what makes it fascinating to us. Besides having this rich protein in a plant, great for you if you're thinking about, you can't bring animals with you to Mars. If you do, that'd be really, really expensive. So your chicken and your pork and your beef, probably not going to have that. Well, you have lab-grown meat? You may. But your protein's there in plants, so we'll give you everything you need as well. And that's going to taste important, that it creates more nitrogen than it needs. And nitrogen is a really big proponent of healthy growth in plants. And when your soil is enriched with natural nitrogen, you end up with a much more productive crop yield, much more healthy plants, in addition to some other key chemicals. But artificial fertilizer, although it really boosts production, really runs havoc on your topsoil. In fact, the United Nations predicts our healthy topsoil is going to disappear within 30 to 60 years, unless we really start thinking about the way we manage our crops and our soil. And so dumping artificial fertilizer on our soil is depleting it at a rapid rate, getting us very high production, like a whole bunch of corn, this monoculture, but really reducing the yield potential over the life of the soil. Not good. So using natural things like Rhizobia in the soil to produce this extra nitrogen helps us with this abundance that we're looking for. In fact, our Native Americans here in North America understood this, and they had something they grew in their gardens they called three sisters. Squash and corn and beans growing together really created this very fertile, nutrient-rich soil that enabled their plants to grow season after season. And so some of you may already be doing that in the gardens. I know my older son really is an advocate of that, these three sisters planting methods. You have wonderful corn at the end of the season. You've got your squash and your beans as well. So what can you do and you can build your own little garden just right there in your windowsill in your kitchen or on your back porch. But let's look at some life and what we can do locally there as well. I don't know if anyone else wants to weigh in on that, but I think this is really important as we look at these relationships. Just from a view from Earth, if you look at the Mississippi River Delta, after all the rain up in the Gulf of Mexico, that's all from your fertilizer that's coming down from all of the farms down to the Mississippi River. It's not healthy. It's killing the Gulf of Mexico. And it's destroying the natural landscape. So what can we do with natural fertilizer using this relationship that's been in existence for many, probably millions of years, bacteria and these legumes? And bacteria and the symbiosis occur in other plants and other relationships. kind of above my knowledge level, but if you have an interest, you might want to explore that a little more further along as well. Let's see, I guess we should probably talk, Tony, about all of the different, across any grade band. We have university students that are involved in this investigation with us as they look at epigenetic changes that might occur to a plant in a microgravity environment. Different stresses on a plant means the proteins will express themselves in different ways. So that's pretty fascinating. Can we unlock a secret to a plant that we don't know through its evolution here on Earth with gravity? And understanding that secret, could that lend to a plant that can grow in a more drought tolerant environment, or some other benefit? Can it produce a higher yield? So we're kind of looking for secrets as we're there in space.
Well, right now,
So anywhere from the epigenetic research on the upper end, just be learning about photosynthesis. Yeah. Go ahead, Tony.
yeah, right now,
Tony,
looks like there are more Lodi students popping on YouTube.
Oh, fantastic.
I also just found the video from Kristen McAuliffe balloon launch.
Right.
I think it will be a great little video to show right before yours.
I love that.
Yeah.
So there's two videos then. I don't know what, I can't see the time here as I'm running the Zoom, but as we get closer to the top of the hour, let's show, or we can show that now, the Kristen McAuliffe balloon launch. But also we have that prep launch video. I showed what we normally do to prepare this balloon to fly as well. That short little video we can look at is. No audio, Tony.
Can you guys hear it?
I hear it now.
And no volume, I only hear Ted.
I'll try to be quiet.
I can hear it. But I'll just add that we invited Peter to come do this with us. So the sixth graders came.
Did you already run the video, Tony?
Yep, it's still going. Almost done.
Oh, I see it.
That was a great launch.
Yeah.
It's been exciting in our STEM program, helping our students understand the importance of science.
Okay, go for it.
Wonderful. So yeah, that large balloon there that Sam McCoy's class launched, is much larger, goes up much higher. That goes up about 19 or 20 miles into the atmosphere, well into the stratosphere, above the ozone layer. This little payload here won't go nearly as high, but it should go much farther. Hopefully farther than last week. All right, I'm probably be able to take my mask off here at the top. I don't see anybody. But behind me, a nice, beautiful view of the San Francisco Bay. I don't know if you can see that. Golden Gate Bridge, San Francisco skyline. Can you see that?
Yep.
Great. Just gonna work my way to the top of the hill here. We get a nice launch. And then I'm at the Berkeley Marina this time rather than the Albany Bulb. And I'll spin around, you can see the 880. A lot more traffic than just a week ago. I think people want to get back to normal. This is a beautiful place for a kite festival. Usually happens during the summer.
Yeah.
All these amazing kites up here. Really nice to come out here to do that. All right. So what time we have, Tony?
We have a 9:01.
9:01. All right. I guess I'm right on time. Now, this is running on solar power, and I had it indoors all morning, so people want to get back to normal. It's going to take a little while to charge up. So it's going to be aloft. It's going to be in the air. And there she is. Hi, Dana.
Hi. Sorry.
Oh, hey, great to see you. Straight on the hour there, and your kids are with us.
Yeah.
Yeah,
Awesome.
we have
Good to see
quite a
you.
few Lodi students on YouTube.
I see them. I just said sorry to them on there.
Oh, no, that's fine. We know how crazy this new world is, right? And thank you for joining us. Diana is another teacher at Lodi. She's at Julia Morgan School. And oh, so frustrating. I was working with your students and Anthony's students at John Muir, and they were cross-collaborating. This is so amazing, where Anthony's students were kind of like the engineer team, right? And your students were the science students. You want to talk a little bit about that before we do a countdown and let this little baby go?
Oh, they were so excited. So Ant's team was engineers, but ours were the scientists, like you said. And they were trying to plan all of the things that were going to happen within the balloon launch, the plants, the poor, I can't think of what were they, we ended up, the Venus flytraps, and how their science experiments, bookmarks, all kinds of things. And that was supposed to be happening probably right about now, but.
Yeah, I know. I kept it on my calendar just to remind me, hoping that we'd be able to do that. But we're going to do these instead. We're going to do these every week. And, you know, you working with Sam and maybe Christina Colburn from McNair High School as we prepare a circumnavigation. Now, the balloon we're going to use is different than the ones you guys are used to, the big latex, and different than this Mylar. It's a plastic balloon that's going to be underinflated, just like this guy right here. It doesn't really look like a very inflated balloon, right? But we just need enough lift to get us up at a certain altitude. And that's the other balloon we're going to be trying. We're going to do a few of these first, just to get comfortable with how this works distance-wise. But I think probably in about 3, maybe 4 weeks, we're going to try one of the big ones to go all the way around the world. And then we've taken on a challenge. So Lodi is challenging a school district in Southern California on a balloon race across the United States and maybe even around the world. How fun is that? But we want our students to be thinking about the Earth as a whole. We're just a couple days after Earth Day, but every day should be Earth Day, right? As we think, yes.
Well, what is the call sign today?
Oh, the call sign today, if you want to track your balloon, and actually, can you just do, there's a little pre-roll I ran last week. It's on our YouTube. It's an unshared.
Oh, right. Okay, hold on.
It's just a minute long. But the call sign, you can go to a website called aprs.fi, and we'll publish that, probably put that in chat in YouTube or what have you. aprs.fi, that's Finland. And so that gets you to a website. It's you'll see it as a Google map with a bunch of marks on it. And it's showing you different radios that are being tracked. These are ham radios running on the APRS protocol, a packet protocol to send data. And the call sign is KK6, so Kilo 6, UUQ, Uniform Quebec -3. So this is the second launch for Magnitude Live. It's the third launch for Lodi this season. All right. So I think we're all squared away. Unless there's another comment.
Don't let go yet.
Oh, you're gonna do that video?
Yep.
Okay, it's going now. Hey guys, okay, so this is what we're putting up in the air. We're looking at a 1 meter wide party balloon, mylar party balloon. We put a little intake here, a straw. It's going to be filled up with helium. And what we're going to normally be using for our larger latex balloons is just a connector. And normally we don't use something this big, but I've got a regulator in here to regulate the pressure coming from this 125 and I'm not going to need that much in here. We're only going to use about 2 or 3 feet to get this thing aloft. And so that's the balloon. All right, so we're just about ready to launch this balloon. Well, first thing I wanted to do after we filled it up with helium is get just the right amount in there where the balloon is neutrally buoyant. It basically kind of floats in the space that it's in. You can see it's a little on the heavy side, but I'm going to call it good. It's about 3 grams positive lift is what we want. When I said neutrally buoyant, that was with an added weight that included the calculated weight here now at the end of the line. And what I've done here is added a nickel, which is equivalent to 5 grams mass. And we should see the balloon fall slowly. Great. So, all right, then we'll talk about that nickel, which is about 2.5 grams equivalent of weight. And what we're going to see is that the balloon is going to rise. Great. And so just using a nickel and a penny, we're able to get a calculation that we know we're going to be lifting between 2.5 grams and less than 5 grams. All right, that's a prediction from the last week's launch. This week's launch is very similar, easterly. It's going to be traveling a little further south. I understood it was around Florida. I'll share the map with you guys as well. Our students that are involved can track using NOAA data, National Oceanographic and Atmospheric Administration's data, and we'll be providing that information with them as well. So Diana and Sam's classes are really here just to kind of see what this is going to look like. They're going to do some more deep investigations in the coming weeks with us as we prepare for that circumnavigation. And you're more than welcome to join us and our students on this investigation, along with our Leguminaut challenge. So no beans on this launch. I know how much Michael wanted us to add trifolia on there, a little clover, but we're just going to launch this balloon all by itself. So I'm a little after the hour. I want to put this up in the air. So how about a countdown, people?
Hey, 1 second. KK6 UUQ-3, correct?
3. KK6 UUQ-3. That's correct.
Yeah. So it's not appeared yet on.
Yeah, and probably won't,
APRS
Liam. And good morning, Liam.
Yeah, hi there.
The indescribable voice of Liam Kennedy.
Uh-oh.
All right, so much better weather today, Liam, as you can see.
Yes, yes.
I'm at the Berkeley Marina this time, and behind me is a San Francisco skyline.
So pretty.
It's a beautiful day. So, all right, how about a countdown, people? 10, 9,
8,
7, 6,
5,
4,
3,
2, 1.
And it's going to drag along the ground, and here we go. She's off. There's an airplane right there. Let's hope we don't collide.
News at 11.
There you go. Oh, don't hit me, airplane. Oh, he's flying right next to us. Oh, he's flying. Okay, that's good. And do I got that in?
Yeah, we can see it.
It's a nice gentle lift, isn't it?
Yeah.
All right. So probably in about 5 minutes, maybe 10, you'll be able to pick that up on that aprs.fi website. Kilo 6, uniform Quebec -3, KK6 UUQ-3. Nice, gentle, right? It's just like I was at a party and I accidentally let my balloon go, except I've got that tracker on it with the solar panels, APRS radios measuring, and we're conveying temperature and humidity and pressure data, which will give us the altitude. So that's pretty nice. And we'll see how far this one goes. I think it's going to be better than last week for sure. All right, I'm working my way back down to my garage. So anyone want to chat a little bit about these balloons? We can do that, or we can just jump right back into the Leguminaut challenge, which I think is pretty important. We've got at the top of the hour, I think, if I'm not mistaken, we've got an amazing vegan restaurant from Orlando, Florida, that C found called Leguminaut. And they're going to give us some recipes that we can make at home using legumes. And we'll have a new recipe every week. That'll be pretty cool. They're coming up at the top of the hour. But who wants to pick up the mantle here for a little bit as I get back to the car and talk more about our program and how it's inspiring your students or how you can get started?
Hey, Liam, you want to talk a little bit about the ISS Above?
Oh, okay. There you go.
That's really relevant. That's really important for our library.
Right. Okay. Let me just switch things back to. In fact, temporarily, I'll just switch me back into the frame here. So, hi everyone. Yeah. So you may see. That's right, Steve. I'm not sure whether we're on the grid view for the audience watching on YouTube right now, but you'll see various teachers here use a product that I created. Steve is pointing to his. In fact, just in case, I don't know, Tony, are we on grid view to the YouTube or is it on speaker view? Because if it's speaker, people can only see me.
Okay.
Anyhow, and so
I'm pinning you now.
Oh, you're pinning me. Okay. Yeah, no, I was with the grid view, you'd have been able to see what Steve is doing. So yeah, because you notice that Steve is holding up an ISS Above sort of right there. In fact, so Steve, how long have you had an ISS Above in your classroom and now at home?
I've had the one in the classroom for probably about 3 years now. I got this one just about 2 months ago for here at the house, since the one at school is stuck at school. So I want one here. So now I have two.
There you go. Yeah. So the key thing about the ISS Above is that it does two major things. One of them is it tracks the space station and lets you know every time it's above the school. And this is quite an unusual thing. Many people are not aware of the fact that the space station passes by your school 5 to 8 times every day. So it has a really bright LED sitting on it that lights up every time the station is above. You'll see it's flashing green on Steve's right now. And that's letting you know it's less than 1 hour away from where Steve is in Atlanta.
30 minutes.
Yeah, there you go, less than 30 minutes. And then on my screen, if I just switch over, this is one of the screens for the ISS Above. This is the orbit screen. So you can see right now, it is just above the northeastern tip of Australia. And it's currently in darkness. And in 11 minutes, it will be sunrise on space station. There are about 16 sunrises and sunsets almost every 24 hours on the space station. And you can see, even though it's all the way over there in Australia, it is literally going to be passing by in the skies above Atlanta in 30 minutes. So, and because I'm in California, it's showing there that it's going to be passing by California in just 23 minutes for me. But it tells you when the next visible pass is. So for those of us in Southern California, in fact, most parts of the USA at the moment, we're coming up to a bunch of visible passes that are all happening at a crazy early time in the morning. So hands up who, while we're on lockdown, is getting up at 5:30 in the morning.
My hand is down.
Yeah, my hand is down. That's right. My neighbors who all work in the ER and other places like that, they are definitely up at all hours of the night. So shout out to anyone who, essential workers that have to get out and do that. The ISS Above is showing all this information, shows who's up there on the space station. Yeah, there's only 3 people in space right now. 1 US astronaut, Chris Cassidy, and 2 Russian astronauts, or cosmonauts, as we should call them. Oh yeah, tonight, just for this, the ISS Above gives you news related to live events on the space station. There is a rocket launch tonight to the International Space Station from Kazakhstan. We're sending them a bunch of supplies on a Russian cargo resupply vehicle called the Progress. And that will be covered on NASA TV tonight. And then it will arrive just 3 hours after launch and dock automatically with the space station. Anyhow, that's vaguely what that is all about. I just sort of jumped in and shared a little bit about the ISS Above. Thank you for the opportunity to do that, Tony.
Well, Liam, if I can just share, what's really compelling for us with the ExoLab and the experiments that we run on the space station is we have museums like out there in Rhode Island with Renee, and we have libraries like at Lodi Unified School District that have our ExoLab set up, or will have our ExoLab set up, running this experiment. And it feels a little distant. Here's this thing that's connected to something that's above us. It might be over our head half a dozen times a day. But what makes it tangible is when we can see our beautiful Earth in real time. And when that's set up in the library, it's kind of like a bug light. The kids visit the library in our K through 6 schools at Lodi once a week. They bring their books in, they drop them off from what they've read that week. They pick up other books. But when they come into the libraries that are set up with the ISS Above and the ExoLab, the first thing they do is they kind of throw the book on the counter. I've watched it happen. And they rush over to see what's happening with the experiment because they haven't seen it in a week. Or maybe they dropped in during lunch to take a peek, but usually they haven't. And then they look at the view of Earth if it happens to be showing at that time. And it's absolutely amazing. The questions that come out, they're just thinking extemporaneously about all of these things that normally you may not have a classroom time to do that. And so it's a chance for them to imagine, to be creative, to think, and to ponder what possibilities might be. And this is some of the most amazing questions. We've had some libraries that actually set up a little question box because the librarians get a little overwhelmed. In fact, I'm gonna give a shout out to Lupe, who joined us on our Wednesday conference. She's right now, she's a librarian at Lodi. She works at 2 different schools, but they're tasked with repairing the Chromebooks that the students are breaking during the quarantine. Right. So apparently especially younger kids, they can't keep those Chromebooks working too well. So she has to work on those. Wow. But their librarians do an amazing job to inspire the students. And I just want to shout out to our librarians that do extra work, not just putting away books and checking them in and out, but really answering questions for students. So they put these question boxes in the libraries for the students that really have this question that really no one has time to answer, which is sad. Everyone's super busy. But one of the most endearing questions for me came from a little 3rd grader, and she wanted to know, and it's just stuck in my head, and it really had nothing to do with our space station experiment at all, but she wanted to know how high a bunny would jump on the moon. And so we turned that into a great little math problem, and we actually I had to look and see how high a bunny could jump here on Earth.
but 1/6 gravity on the moon. We could do a little quick calculation. It might have been a little more advanced math for their third grader, but nevertheless, I think she was happy with the answer that she got, that it could jump pretty high. I think it was 27 feet or something like that, if I recall correctly. But of course, you'd need a bunny suit. So I wanted to know what a bunny spacesuit would look like. I never did get a reply. So I'd like to see what that artwork might look like if a child decided to build a spacesuit for their animal, their pet, whether it's a dog, a cat, or a bunny. It'd be kind of neat. Anyhow, so Liam, thank you for the inspiration of your device. I think it really connects viscerally to people, and it draws them in and makes them curious. It's a view we normally don't see, and very few people actually do get a view like that. Astronauts call that the overview effect, where suddenly we realize not just how small we are on the planet, but how small the planet is in relation to everything else around us, the universe. Maybe modern civilization, we've kind of, in a way, really isolated ourselves from the rest of the universe. This the light pollution that we have, we can't even see the stars anymore. But I guess there's silver lining in something like staying at home. A lot less cars on the road. The skies are a lot clearer. In different parts of the world, normally weren't able to see the night sky. Can now see the night sky. Not all the stars, obviously, but many of the stars, the brightest stars, they can see, and they can see the planets as they go about their orbits. It's quite beautiful. So here's a time, I think, where we can reconnect with nature. And as we think about, I'm going to weave this back into our legumes, we think about growing plants. I imagine many of us have gardens, but for those of us that don't, or forgotten that we can probably do that and have some fun, let's get our students and our children out there and do some gardening, or just observing the different insects they might see in their backyard, or counting the different flowers or the different bird songs they hear in the morning. I think this is the perfect chance for informal learning. School is now homeschool. And so what does that mean for us as educators? What does that mean for us as parents? I think this is a time for us to have some fun. And not just think about the next test that's coming up. Although there will be a quiz. I might get dropped, but I'll...
Yeah, I think it's that transition. Yeah, transition to your home Wi-Fi from when you're driving up, right?
Yeah, I think that's it.
Yeah, that's right.
In the driveway.
I'll just jump in. I mean, I think this is a great the Leguminaut Challenge is really a great opportunity to work with something that's living and vital, and that you have some control over. So all those social needs that it can fulfill, but to really impress upon people that this is real research. We have to be able to produce food in a sustainable way, both here on Earth and off planet. If we're going to go any further than the International Space Station, we can send a resupply up, as you were talking about, Liam, every couple of months, and send up new clothes and clean draws. But you can't do that when you're on the moon, or on an asteroid, or on Mars. I mean, on Mars, it's going to take years for a resupply. So you're going to have to be a whole lot more self-sufficient. And so with the way that my 4th and 5th graders are approaching this Leguminaut Challenge is with our lockdowns, we're all on planetary outposts. And the resources we have are the resources we have. There is no resupply from Amazon to space, at least not yet. Jeff Bezos is working on it, I know, but
yeah, he's building his own rocket.
Anybody who can burn $1 billion a year on space exploration is all right on my book. So maybe he'll get it there, and we'll have Amazon Prime to Mars, but it's still going to take a year to get there. So you've got to be able to use what you have on hand. So what do you use for potting media if you don't have soil? If you live in the inner city, maybe you've got a little square meter of soil around the tree that's planted in front of your building, planted in front of your building, not so Freudian slip. But it might be rock hard for all kinds of compaction, because the ground's frozen. Maybe you don't want to touch it because that's where people park their dog. So it's maybe not, you don't have a source. So what can you use instead? Well, I know Steve has been experimenting with using Knox gelatin. I've got students who are going to try using shredded up newspaper. Somebody was talking about using some cotton balls, sand. Maybe you want to go for the hydroponics solution and just use a piece of felt or an old T-shirt as your wick to let the roots of your seedling embed into. I know Diana's experimenting with tea bags. And then Steve and I are as the original coffeeholics. We of course are using spent coffee grounds as potting media and experimenting. And right there's even this K cup. So he's trying to be a little more ecologically sound. You know, we'll talk later about those K cups there, Steve. But they do good. They do make great science equipment right now. And that's the other piece is you got to repurpose. You don't have beakers and graduated cylinders and all the labware that your test tubes and whatever that you're used to having in your classroom that your students are used to having access to. Again, we don't want to be ordering this stuff from Amazon. We don't need to be spending our money on stuff like that these days, even if, you know, and some of us, it's not even a question. But I bet there's stuff in your recycling bin that could be repurposed. I found some, I mean, there's people in the room that are old enough to know what these are, but I showed this to my students. They had no clue what this was. And I'm seeing blank faces here.
I have to get my glasses on.
I'm showing a blank stare from the earth right now.
I know.
I have
wow,
no idea what that is.
Incredible. This, okay, before digital cameras, we had this celluloid material that was in a light proof container, a little cartridge, and that cartridge fit inside this little canister. And you would take this to your local corner store and give that cartridge to someone who would then send it in the mail. And about a week later, you'd get back an envelope with prints of the photos you took. About 24 of them, 36 of them, because there was a limit on how many images would fit on this media.
Was that called Instagram?
Way before Instagram. The last time I actually bought one of these, I think it was the previous millennia. So these were film canisters, and I used to, because these were so great as little pots to get plants started in, I used to go to my local film developer and ask them, and I would garbage bags, big garbage bags full of these things. I'm down to my last, I've got about a cubic foot of these left. So I'm going to have to come up with a new ideal container. But there's, you know, anything can be repurposed as a pot or a germination chamber.
We're repurposing pill containers. So
yeah, that's a good substitute.
We're using those, and I love the green, not the see-through ones, but the clear ones. The green one is pretty cool to work with right now.
Oh, interesting. We don't have green ones here in the States. We have amber and clear.
Sorry. Yeah, so we do have those. We also have some darker ones too, depending on what type of pills that you're getting. Sometimes our pharmacists will actually give it to us because we are classroom teachers. Yeah. We'll ask for empties and you'll get a little bag of that. Just very quick, because I see the kids are coming in. Ted, you were talking about outdoor gardening, and you fostered something in my mind, and that was, what do we have to do here to protect our gardens? But a good question I will pose to the students out there, what will we have to do to protect the Martian and Moon gardens? What are the unknown factors about protecting those gardens? So we do have, you know, the humidity, the exposure to different things, the CO2 levels and all of that. But what else is out there that are unknowns that we might have to protect ourselves or protect our gardens with? So I think that I'm going to throw that investigation out to the students this week in an email and see what they come back with.
I almost said something, but I'll be quiet. I'll let them investigate those things. My thinking starts with the letter R.
I know.
Hey, it looks like our little balloon is starting to give us a little blip now, which is nice.
Yep.
And we're at 2,700 feet. At least that was my last reading. Traveling about 16 miles an hour, heading essentially due south is what it looks like.
We have some student from South Africa on the line.
Oh, fantastic.
Great
Are
to
they
see
here
you.
inside Zoom?
Yep.
Or in YouTube?
I mean, you can read it. They
Who's
can
joined
read
us?
I sent them the link, so I'm hoping a couple of them are joining and asking. So we'll let me check.
We have a couple of students from Mexico too. They're going to be talking later on.
Awesome.
Great. And feel free to give a shout out here if you'd like. And I see some students from, I recognize Kayla from Florida, right?
From Florida.
Yeah, right.
Yeah.
Good to see you. One of Laura's students. And Caleb, you're with Laura's class as well, I think. Caleb's with Laura's class. Yeah. Okay, cool. Good deal. Oh, great to see you guys. And you're probably bringing some more questions along with us, I hope, or maybe sharing some of your research if you've started to do some plant investigations. We'd love to hear from you. This is kind of an interlude here. We've got about 30 minutes before we have some guests share recipes with us from Leguminaut. So, see, you had an for me. I've kind of like that is, and open it up to many of our principal investigators are here on the call today, and many of you joining if you're here on YouTube. We have this as an open challenge. There's no cost at all. We need to find the right candidate to send to space in February. And we moved the flight twice because of this pandemic. We were going to originally fly in August. We moved it to October. Then we thought we wanted even a little bit more time, so we moved it to February. But what we didn't do is we didn't extend our design time. And we're thinking we'd like to extend that to really do more ground trials with everyone. So who would like to actually get involved? It's never too late, but I think we're going to extend this time. So just to show of hands, who would like a little bit more time to do these trials and maybe even try some different seeds as well? So we're debating that right now, but we might be able to take it all the way through summer, providing we can still meet NASA's objectives of delivering the materials that they need in time to go through their toxicology checklist and their the mechanicals checklist and the noise levels and all the other things they're going to make sure our experiment does. But today, as it stands, we're looking at the end of May before we make a decision on which legume we're going to fly. But we're thinking we're going to extend that 30 days or maybe even longer. So anyone want to chime in on that? Would that be a good idea to do? You can run a couple different experiments. I think our students would love to do that. They haven't started. I see a thumbs up there from Liam. I don't know how you did that, but that's pretty cool. Thumbs in space. thumbs.
The reaction, there's a reaction link.
Oh, great. I need to learn how to use that. Okay. I feel like a really
there you go. And I'll just
hey, I learned how to do that.
It's a new feature. I've never seen that before until today. So
how do I get rid of it? I just click it again? Or
no, it disappears within a few seconds. Yeah.
All right.
So, yeah, look at all those thumbs up.
Wonderful. So we're going to extend it. We're still determining how long. PIs, give us some feedback on that. I do know that we have this natural break normally during the end of the school year and the start of summer. Some schools are extending that. Some have already ended. It's really kind of open-ended. But we think we're going to use that normal demarcation of end of regular school and the start of regular summer as a chance to move maybe toward a professional development for educators. So if you're new to this, you're just tuning in, you're a teacher saying, you know, I'm just trying to deal with getting things set up and I would like to get ready for fall. This is the perfect opportunity. We're going to be moving all of these projects that we're working on through the summer months, getting ready for fall. I'm hoping everything's back to normal here, but I think if anyone is prudent, they're going to be making plans and making preparation for understanding how to teach and learn when our students aren't in the same room with us. And I think this is pretty much the experiment we're doing right now live with you guys. How do we engage students and educators and people around the world on a project when we're not all in the same room? So we're pretty excited about that. And Lori, it's good to see you. And I'm so glad you brought your students in with us. Would you like to do a quick introduction there or anything you'd like to comment on in terms of what you guys are working on right now there in Florida?
Sure. So I have, I think 2 of my students are on right now. Another one might be joining in a little bit. We're looking forward to hearing from the chef in a little while, because we just studied and did a major portion of this project on looking specifically at nutrition of legumes and exploring different recipes with them. And so I don't know if Caleb or Kayla want to mention what they found, maybe some of their findings on the nutritional aspect of their specific legume and the recipe that they chose. Do you guys want to mention that real quick?
Sure. I'll kind of talk about mine. Like, one of the main reasons when I started looking at mung beans and like choosing that for my project that I was working on was because of the nutritional values and how easy it was to prepare. So a lot of the things that mung beans have are like very high in protein and amino acids, which is very good. Just lots of like different a lot of different vitamins and minerals like calcium, vitamin K, iron, just very high in that, just able to like to get a lot of your nutritional value from like one source and not having to have a bunch of different things to get all of your nutrients and all of the vitamins you need. You can get a lot of those just from having mung beans in that diet. Also, it can do a lot of other things, especially lowering cholesterol, and that can also help, especially for like high stress and eating different things that maybe like could make your cholesterol higher, which isn't the best thing. So I feel like having mung beans has a lot of different nutritional values, and it also helps it can also help build tolerance to different things. They have like several antibacterial phytonutrients, which can help people build up tolerance to different viruses and different things that may be around.
Wow. Okay, that's a lot of info. You know what I like about
Extensive project that they had to do. We really emphasize, since they're high school students, being able to research and find data and studies and reliable sources, as well as them properly citing information in their research. And so these are all really crucial skills that they're going to use throughout high school and college. So I'm using this as an opportunity to do this project, but also really narrow in on these fundamental things that'll carry over to other types of learning, whether it's in science or history or English. Having that research and writing component and that strength is a benefit to scientists, and scientists have to learn how to communicate their results. And so I'm using this project as really a mechanism for that too. So Caleb, do you want to jump in here?
So I found that alfalfa, it has a lot of protein. It also has iron and other nutrients that you need. Has vitamin C, I think it was. Just has things that your body needs.
Have you been able to grow that pretty successfully so far, your alfalfa?
I haven't actually been able to grow it, but
you know, I like that with the clover because the seeds are so small. There's so many that can grow in the same volume. At least I've had a chance to grow everything, at least for the first 2 weeks here. And I'm just going to go back to the mung bean. It's got to be the most beautiful plant when it's just coming out of the ground. The color that the seeds, it kind of turns this purpley magenta, and then it grows and it almost looks like a little palm tree as it gets a little bigger. And I'm just hoping for that nodulation, right? So this is our big experiment. Getting those plants to grow and having something harvestable is good, but we also want to think about how it can act as a natural fertilizer. So one of our challenges is not just selecting this right, whether it's an alfalfa or mung bean or cowpea or chickpea. One that's in there we haven't chosen yet is like peanut. There's a number of beans that we haven't included. So if you have your favorite legume, and it's not in our list of who we're going to send to space, but you really love this, well, why don't you be an advocate? Tell us why we should be sending your plant to space with us on this experiment. But what's interesting here is that nitrogen fixation. We're going to have to find a way, once we've selected the right legume that we want to send up, to get that nodulation, that interaction between the Rhizobia bacteria and that particular legume. because we really want to see how that's developing. And that is going to be our research epigenetically when it comes back to Earth. And I think I saw Dr. Barker join us. I might, if you're up to it, I might send it over to the Gilroy lab and have you guys do the sequencing. I don't know if you guys have got that capability directly, but I think it'd be fun to have that end-to-end there at Gilroy. And so what do you think, Dr. Barker? Do you want to handle that in when, I guess that'd be early April next year?
Yeah, we'll be sequencing some stuff then. Yeah, I'm throwing and bring into the mix.
That'd be great. So, you know, a lot of it's still up in the air, and there are many, many legumes that we haven't even chosen as our initial candidates. Don't be shy. You really love that particular legume. You know, why isn't peanut included? You know, it's like,
hey, Ted, I'll tell you what I learned recently. This is kind of interesting that we have this beautiful wisteria, this beautiful purple kind of treeing flower, right? In our local area. Wisteria is a legume.
No way.
No way.
Yes. Now it's not edible, but it is a legume. It's within that family. So that was just fascinating to see that you have a very broad spectrum of plants to choose from. But I think we want the edible ones.
I do have a bonsai wisteria that I've made. It's in its like 3rd year, so it might flower this year. It's got a little spiral in the stem where I curved it around a stick.
Oh my goodness. So I'm wondering if you're getting nodulation then. Right. Do you think you're getting bacterial nodulation down there?
No idea. But I learned yesterday from the Kennedy Space Center that having too much iron in your diet isn't actually really good in outer space. An iron overload is kind of one of the symptoms in astronauts of the spaceflight environment. So although on Earth, particularly for some people who are deficient in iron, like fortifying people's diet with iron on Earth is definitely really good. But the spaceflight environment is one of those strange places where it's one of the nutrients you don't want. A bit like calcium too. Like everyone knows about the bone loss that you get, all the calcium being removed from your bones. So my first thought was like, well, we want to get more calcium in their diet, just like, you know, fill it back up again. But it turns out that was one of those misconceptions. Like it doesn't quite work that way. If you, the way the calcium is being removed from their bones, from the calcium phosphate format that it's in, adding more calcium into their diet actually causes calcium like balls to form, like gallstones, and you don't want to be trying to get those things out of you in microgravity. So it's actually better to fortify the diet with things that are rich in potassium. So if you were looking to provide if you're looking for a nutritional component to be one of the deciding features of the legume that you'd send up, one of the most valuable ones would be a rich potassium quantification.
And also folate. This morning, I was on a call with one of the nutrition scientists at Johnson Space Center, and he went through an entire just fascinating presentation on the need for the B vitamins and folate being so key also to ocular, to eye health.
It's funny you should say that, because in the transcriptome of the Arabidopsis plants that are going on space, we see changes to their B vitamin metabolism. So we think that the plants also need it, but they have the genes to make it, so they're like switching them on. But we don't as humans, we have to eat it. So like that's another one of those like, yeah, really important nutritional components.
Yeah, he said it was so key, and he thinks vitamins are really the answer, and then it'll be up to the food lab and the folks at KSC, decide on the plants, so which ones are rich in that. But the other thing he emphasized was that density of nutrition, not only in calories, but also those nutrients. So how to get the most nutrients out of something. So with all the lettuce that they're growing on the ISS now, that's great. But lettuce really isn't as nutrient rich as some other types of plants. So he was interested. I mentioned the Leguminaut to him, and he was intrigued as to where we would take this. So pretty exciting, because he was even getting down to the biochemistry part of it, and the genetic predisposition of astronauts and how their eyes are being affected, and whether or not it can be resolved with these B vitamins.
Wow. And so, Lori, this is someone at the food lab? Who is this?
Yes. Yeah, his name is Scott Smith with he's one of the nutrition lab scientists.
Let's get him on the show.
I'll try. This was as part of my graduate school that my professor got him to speak for a little bit. So I'll see what I can do to connect more directly with him.
Or maybe we can ask Liz Warren, not Elizabeth Warren, the politician, but Elizabeth Warren, the scientist that works at the National Lab there for the space station, or maybe get her back in to talk a little bit about nutrition requirements for our astronauts, our cosmonauts, our taikonauts, those that go beyond Earth. Right? What?
And leguminauts.
Oh, and leguminauts. Well, our leguminauts, I guess, we're going to need different kinds of nutrients for those guys, aren't we? I was thinking more about the human condition, but let's make them the star of the show, though. So that's great. You know, there are so many different vectors that we can take this learning experience on. Liam, for example, is just showing us right now this beautiful animation of the different components of the space station. If you look at his screen, I've got it up there where you can see everyone that's in the Zoom. And it's just calling out the different modules they're putting up there. If you have an engineering interest, how is that thing able to stay up there in space? What do you mean it's always falling? You know, explain that to me, you know, and so it is always falling. It's traveling very, very fast. And since it's always falling, it has to travel fast enough where it keeps on missing the planet. And it's essentially a definition of an orbit, right? You're just going around and this round body, and it keeps on trying to land, and it's going so fast it keeps on missing. 17,500 miles an hour. As Liam said, you get about 15 sunrises and sunsets every day. It's quite a wild ride. And soon, I think citizens, if it's not going to cost tens of millions of dollars, will find their way up there to join the researchers, the scientists, and the engineers as they discover new things for making life better here on Earth. So you've got engineering you can experiment with and explore. You've got human physiology. How are we affected? You know, Lori's talking about our eyes and our fluids, and you know, Dr. Barker's talking about our bones and calcium and what happens if we have too much, or iron, and then our plants themselves. But you know, if you dig into it, there's this whole ecosystem. Our plants just don't grow by themselves in dirt. There are these there's these living things in there, these microbes. There's your little, I mean, we can get into entomology and think about all the little bugs that are in your soil that are helping making things work. It's kind of hard to run soil experiments in space because NASA wants to irradiate everything to make sure there isn't anything that's going to affect the astronauts. Of course, if you had something that was disastrous up there, like a microbe that got out of control, then that would be, you know, very difficult for people living aboard essentially an RV that you can't leave. You know, you can't just go out for a breath of fresh air. And so they really like to contain this stuff. But I would love to see some living soil in our experiments. Right now we use an agar, a gel medium, gives us all the nutrients, great for initial plant development. It's not going to be very good if we're going to look for a full plant growth and some of this nodulation at the roots. So I don't know, maybe one of our educators here might want to chime in on what is actually happening there at the root level. We'd love to share that. And I think we'll probably get close to the top of the hour here where we can get some recipes from a Leguminaut there in Orlando, a little vegan restaurant. It's going to join us.
Ted, I want to back up just a tiny little bit. I had to upload the image. I was just doing a dissection of some cowpea roots that the plants are about 2 months old. Okay. And we got some really nice nodulation. So just to kind of make this real, the nodule in the image that I'm about to share with you is about 3 millimeters across. So this really shows you some detail. You can see how it's literally growing out of the root. And then I've got a cross section here, and this outer tissue, the more yellow, is actually the root tissue that underwent a genetic transformation when it was infected by the Rhizobium. And then the dark center is where the Rhizobium was actively fixing the nitrogen in exchange for the glucose from the plant.
Shall I introduce root physiology from like a kind of
Yes.
I've got a slide on that, and I can introduce some of the calcium signaling that occurs between the Rhizobia and the roots as they communicate, but from a kind of crazy perspective. Okay, so seeds, not seeds. 2 seconds. So walls. Yes, here we go.
Oh, great! Look at that.
And this is a new one. So this is all like unpublished kind of data. So it hasn't been peer reviewed, because in science you have peer review. So you come up with ideas, you come up with stories, and you show them, and then you write them, and then you submit them to journals, and other people who are peers in your field, like your friends in your classroom, look at your work you've done and gone, yeah, that's legit, or nah, there's some artifacts there, there's some things I've done wrong, perhaps you should do a couple of other experiments to try and support your claims and ideas. So what I like to believe is that plants communicate with each other. So there's one plant in the background that's touching its neighbor here, and we're just showing a signal moving through it. Hang on a second. So back to the beginning.
Wow.
Hang on, I can press play. So this is plant A and this is plant B. So you could also, so this signal too, if we now put Rhizobia next to those plants, this like slow increase in calcium in one place or another would, rather than going from plant to plant, would be going from like microbe to plant. And they've learned to use these signals to coordinate their growth. And what this is really important in root hairs. And so this is why I wanted to introduce root architecture and root physiology in general, to show you like just why root hairs are actually really awesome, really interesting. Because that nodule that was shown earlier, that how big was that again? The one you measured?
3 millimeter, I think.
3 minutes. That's one cell that's just swollen up, essentially.
It's
anyway,
a single cell.
Yeah, that's then got tumorous because of the communication. But then that tumor is providing food, so it's happy, so it's feeding it. But so we'll come back to that. So root hairs are fascinating things. So this is some work that's been done by a student in my lab, and I was trying to get him interested in moss because we had this mechanism to look at calcium signaling in Arabidopsis, and then a friend of ours recently put it into moss. So we can start to see the electrical signals that are moving through plants and mosses. And so I actually didn't really know much about moss, so physiology and different stages of development. So I was, again, learning something new. That's the beautiful thing about doing research. You're constantly like learning new things. But some bits of a moss look just like a plant, like particularly this stage of development, the gametophore. Oh, what a terrible name for an organism, gametophore. Oh dear. Why did they create these weird old Latin names? And rhizoids. So rhizoids are like roots and gametophores are like leaves. So you got your root and your shoot. Your up and your down, your green harvesting of light area, and your roots that can go down and find nutrients and probably store sugars that get made, that kind of cool stuff. But moss isn't like a flowering plant. It's got different stages of development. So flowering plants, angiosperms, the majority of the new recently evolved type of plant, have those beautiful flowering organs. But before them, there were more primitive moss plants that crossed the world, moss being those. And when they were replicating themselves, they did it via spores, just like fungus, because of the common evolutionary ancestry of fungus and plants. And so like moss is essentially like a living fossil. But what humans have done is sequenced its genome and then looked at how its genes are expressed in its different organs and in its different stages of development. And we can now look at that and pull that information in computers really quickly and easily. It's all free on the internet. You just need to know where to look. So then I wanted to compare moss to higher plants, because sometimes by comparing and contrasting, you can learn things about both. So this is now an Arabidopsis seedling. So Arabidopsis is a dicot, so it's just like the legumes. It's got two little cotyledons. They come from the center of the seed, like the endosperm. That's like its energy reserve. And in legumes, those are really big, and that's why we like them so much. Their cotyledons are really big and full of lots of protein, and because that's how the seed then becomes a new seedling. It uses that energy to germinate and grow. But so when the seed germinates, you get these two cotyledons that appear. They're before the first true leaves come and grow from the shoot apical meristem. You then have like your primary root that grows down. And your primary root has these root hairs that come off it, and they're really sensitive. They sense the water and the nutrients that are around them. And I'm going to try and convince you that they then communicate some of those things they perceive to the rest of the plant. Similarly, on the leaf top, where you've got your leaves, you've got an important like structure to the leaf physiology. So you have got trichomes. I love trichomes. I think these things are fascinating. You've also got stomata. These are really well documented. They open and close to allow nutrients and air to go in and out. So your gaseous exchange, bringing in carbon dioxide for photosynthesis, bringing in oxygen for respiration. And this has evolved in so many different ways, and all these different types of plants, like cacti and such, have very customized stomata. But the thing I really want you to get interested in today is the trichomes. So trichomes in many plants become glandular and secrete like different chemicals. So like different smells, all kinds of things. Some trichomes that have evolved in salty ecosystems, and they've evolved to secrete salt onto their surface. So they can move the salt from around their roots, push it up through their leaves, and excrete it on top of their trichomes, so they can continue to move water throughout them. And trichomes are outside of the plant, so they're like really exposed to the environmental conditions. So this is when I go crazy and I put a wild theory out there, which is they're a bit like a tuning fork, and just waiting to be kind of tapped by different types of environmental stimuli, be it mechanical, be it chemical, be it temperature changes, and then transmit into the plant messages that help the plant then respond to those environmental signals. And we've got little snippets of that information in the literature, and we've had to do future experiments to kind of like help people clarify that pattern. But it's a really, really fascinating system. So you can think of plants as being a bit like microcomputers. They have a stimuli, they can perceive it on these little antennae that stick out. They send it through their like solar panels. Sometimes there's an immediate instant response. Sometimes it has to be like the opening and closing of guard cells. You're losing water is lethal, so you have to be really rapid in your water protection system. But then you have the vasculature bundle, and when you see it like this, doesn't it look like the cable that brings the TV or internet into your home? So, well, we always get told about it initially from the water movements perspective. It's evolved to be this shape in order to have a capillary action which forces water up from the roots to the shoots. But in the result of doing that, it's also coincidentally, potentially evolved the capacity to be like a wire, to transmit these long distance signals. When you look into the vasculature bundle, right in the center, next to the xylem and phloem, you have these companion cells. These are the longest, thinnest cells in the plant. Just like in mammalian systems, the longest, thinnest cells are in our nervous systems. Incidentally, when I look at the genes that are involved in plant perception to stimuli, they seem to be expressed in this area. So I'm again one of these wacky scientists who believe that plants have a long-distance systemic signaling system that has many features that are similar to a nervous system, and they conduct along the vasculature to the data processing centers, because that's obviously where all information goes, right? What is the data system processing? What am I talking about? A root tip or a shoot tip, the root apical meristem, the shoot apical meristem. This is the area where the plants are actively dividing and growing. We'll introduce those in a moment. So now you can break down that physiology that we're just going through in the plant into 3 groups: perception, transduction, computation. The plant perceives its environment, it sends the signal, then it computes its response. And the way it sends the signal I was talking about was through these calcium waves. You look at them, they're just action potential moving along a membrane. So it's essentially a bunch of noughts and ones. It's just like a computer. And we're now trying to work out how they decode that Morse code that they're sending through them. work in progress. I'll dedicate my life to that. We'll see where it gets us. So perception. So yes, so the first two parts are perception, root hairs and trichomes. So we discussed these earlier, but now we're thinking about them from a different perspective. Rather than just thinking of them as being physiological things that we're naming on the surface, now we're giving them roles, we're giving them function in a circuit. Root hairs, trichomes sense their environment. They transmit a signal through the vasculature, through the wiring, to the shoot apical meristem and the root apical meristem, which are able to compute that response and do something. What do they do? Well, they change the two things they can change, their cell division rates and their cell elongation rates. So in a mammalian system, that long distance signal would have caused you to jump out of your seat or run away from whatever it is that's burning you or trying to eat you or whatever. But plants can't do that. They're sessile organisms. They're stuck there with their roots in the ground. So when any of those threats activate their system, they have to respond in situ at that location. So they can change their metabolism. They can try and make some chemicals that make them not take that they don't, to make it so they don't taste very nice. Like chilies. Chilies did that. Humans are terrible, evil creatures who then learn to like the pain and continue to make spicy food to this day. But so you can change your internal biochemistry, but also you can control your growth rates in your different areas. So you can try and grow to different areas. And so we're going to look at the root tip here, and all the patterns that we see in the root tip, you can actually find like similarity in the shoot apical meristem and in the leaf structure. So learning one is actually cool because you learn all three different areas all at once. So I've always focused on the root. I think it's fascinating. So here we have a little picture, an abstract picture of a seedling, our proximal end, our distal end. Roots go down towards water, shoots go up towards light. In the absence of light, in the absence of water, the roots will still go down because they detect gravity and they go towards the gravity vector on the whole. And the shoots, but again, in darkness, will still know which way is up because they also have the intrinsic capacity to perceive the gravity vector. How do they do that? How do they direct their growth, and how do they perceive the gravity vector, and how does that control the plant response to all the other stresses in the world? Well, this is the root tip, this down here. We have our quiescent center, these cells here, and they coordinate with all their cells that surround them. These are columella cells. They have these old statocytes inside them. That's a silly old name for an organelle. That's an organ inside a cell, an organelle, that fills with starch and gets really heavy. And then it sinks to the bottom like an anchor. And so that gives the plant direction. That tells them which way gravity is pointing, so to speak. And so these plants then push this hormone called auxin down. You can see these white arrows. This is the direction that auxin moves within the root tip. This is what we call the reverse fountain model. So it's invented by my PhD supervisor, Malcolm Bennett, back in University of Nottingham. Essentially, auxin is made in the shoots. It moves down to the roots, and there is a polar auxin gradient. And this is how the plants know what way is up and what way is down. As the auxin gets to the root tip in healthy conditions, there's a positive feedback loop that makes more auxin. That auxin builds up in concentration and then moves around both sides through the lateral root caps, up through the epidermis to the elongation zone, where auxin, in coordination with other hormones, regulates your final cell size. So what this fountain here is just down here. So we have our auxin movement flowing dynamically around the root tip. And then when the auxin concentration is dipped enough here in the elongation zone, the cells will stretch. So when we're looking at the health of the plant, we can measure the overall size of the plant, and we can also measure the size of the meristem, and we can measure the final cell size. And all these different features will tell us things about how the plant is feeling about that environment. After the cells have reached their final cell length in the elongation zone, you have the differentiation zone. This is the final stage. And that's what this picture here is to help kind of show. Here you can see around the epidermis, this outermost cell layer, you have two different colors. There's this dichotomy, there's two types of cell. There's the trichoblasts and the atrichoblasts. Oh, damn those old-fashioned scientists with their stupid Latin names. Why didn't they just call them root hair cells and the other ones? Oh, anyway, sorry.
The other ones.
Yeah. Sorry, so yeah, stupid name for these cell types. I'm sorry, it's just the way the game goes, right? Sometimes. But then when you use it correctly, you can also make yourself sound very intelligent, and sometimes that's fun. So you should try and say trichoblast and atrichoblast. What you have to do is say it 3 times, and then on the 3rd time, say it like a boss. You know, you just got to own it. With all these Latin words, there's always going to be this moment of apprehension, and no one minds if you get it slightly wrong. You've just got to throw yourself out there. Just like this plant, Arabidopsis thaliana. I mumbled my way through it through so many years and eventually got confident. So don't worry about the silly names, but you have to try and play the game. It's fun. So anyway, the epidermal cells, the trichoblasts and the atrichoblasts, eventually some of them will elongate and they will become root hairs. And there's some interesting things that show in the space-like environment, these hairs don't elongate properly due to changes in the cell wall structure, which is related to gravity and microgravity. And we're investigating that in the near future. So these root hairs, they elongate out, they can have contact with their environment and they can send signals in. But what if, could they transmit a signal out? Dun, dun, dun. Okay. I don't know if I should show you the rest of this because it's all kind of like theoretical and unpublished. But I've been investigating how plants long distance signaling has made systems, many components in the system that are similar and analogous to human mammalian neurological systems. So this is a picture found off the internet of a nerve. It's kind of artistic, isn't it? I quite like it. Kind of makes me think how I imagine it. In my mind, close your eyes, you kind of picture it. Maybe this is in your brain, maybe this is in your hand. I don't know, somewhere on your arm. So there's lots of them in you and I. But then this could be any cell. So imagine this, you can also imagine this being like 2 cells in a root in the center of the vasculature, but they have to have a signals that move between them. And we know that in mammals, in humans, we have these neurotransmitters like glutamate and adrenaline, noradrenaline, serotonin, dopamine. You've probably heard a lot of these terms before. So these are just like chemicals that sit and move between your synaptics, clefts. They just they transmit signals. We also know that calcium is involved in this system. So the movement of these ions, the movement of these neurotransmitters then causes ion fluxes within those cells. And one of the things we've been doing is like generally modifying the plant, adding the mammalian neurotransmitters and then activating these long distance neurological signals that we then visualize as calcium movement. So we're activating the system with glutamate and then we're watching calcium then move out into different parts of the cells. So it's not as fast as it is in human systems. It takes minutes to get there, but you can gradually see signals moving through.
And what's the scale that we're looking at right there?
That was all about half an hour, condensed down.
In terms of actual size, Sarah, that was the 30 minutes, but what kind of magnification do we have?
Oh, that is a great question. I'd say about 10 times.
Wow.
Top head, sorry, it's been a, I've got it saved in a document somewhere. And that's on metadata. So this is another thing, like we were talking about earlier, like of storytelling. A lot of people are scared of telling people about their story, what they did. But you have to be able to put yourself out there because sometimes you get a question that'll make you realize there's some important extra information that's needed to transmit the story properly. So, sometimes it's really hard to take criticism. I know, like someone says, "Oh, you've missed your timestamp off that," and you have to always be able to laugh these things off and take criticism, and then make notes so you can then do better next time. And that's again part of the scientific process. This like whole peer review process. A lot of people are concerned about being wrong, so we often get taught that we have to just like learn what the answers are in the science textbook and like just pass the test. But like it's more than that. It's like this kind of polite deductive reasoning, this dialogue where you present data and perspectives on something of interest. And for me, that feeling of interest revolves around plants and their environmental perception, be it perception here on Earth when I'm like activating them with parts of the mammalian nervous system, or be it in outer space when we've removed gravity and we're seeing how they respond to a stimulus they've never had before, or the lack of a stimulus that they've always had, which is the same thing, right? Microgravity.
Well, Dr. Barker, this is an interesting introduction to just about talking about how Rhizobia might interconnect with our root stem. And I want to dive in a little deeper with you, but we have a guest here I want to make sure we acknowledge. And we're going to do a little segue here to talk about the good stuff we can make with the plants that we grow, right? And C from our team was able to locate an amazing little company in Orlando called Leguminaut. And Beth, thank you for joining us. I think you might be on mute right now, but she's going to share with us just some. Hey there, good to see you. Share with us a little bit about vegan lifestyle, vegan cooking, what great things you can do with legumes. And with a name like Leguminaut, you know they've got to have some pretty awesome recipes. So they're going to be joining us here. They're welcome to join us every week, but they'll join us a couple times to share some recipes that we can make at home, understanding we may not have the most full larder right now, but we might have some dried beans around. What can we make? What's some good stuff we can put together? And so I want to learn more about this connection with Rhizobia and our root stem, but I think that was probably a good place to introduce Beth now that she's here, and Leguminaut. So Beth, the floor is yours. Let's hear a little bit more about what you guys are up to down there. And
all right, well, thank you for having us. So I am a member of the bean team at Leguminaut. That's what we call ourselves. And we are definitely huge legume fans. Predominantly, most of our recipes have some kind of legume. Soybeans we're a big fan of soybeans. They're very versatile, but we use some others as well. We just are so fascinated by what you guys are doing, that we were just like, yeah, let's help out. And I really like the idea of right now in our pandemic kitchens, legumes are such a good thing for us to be cooking. So we have a bunch of recipes that we're going to share with you. The first legume I'm going to start with are peas. So I'm going to have a pea recipe for you today, and just talk about peas and other ideas you can use peas with. You probably have some frozen peas in your freezer that need to be used. You don't know what to do with them. They look boring, so I'm going to help you out. And I'll tell you a little bit about our restaurant in Orlando. Leguminaut was started by my bean team partner, Bex. It was a food truck, and we started a few years ago, and now we have a brick and mortar, and we are neighbors with a coffee shop called Foxtail Coffee. So while coffee beans aren't legumes, they are our bean team partners. So we got our coffee beans, our other beans, and so we have a lot of fun. We make all of our foods vegan, and we like to make food that everybody can eat, that's familiar to everyone. So you're gonna see ingredients like queso and ranch, and you might be like, but queso has dairy and that's not vegan. But we use sweet potatoes and other ingredients, and we end up making this amazing like nacho cheese that's super addictive and really, really good. And it's really good for you and nutrient dense. And we do a lot of that with legumes. So I'm going to teach you how to take legumes and make them into something maybe you don't like beans. Maybe chickpeas don't sound appealing to you, but you like chocolate chip cookies. Well, you can use chickpeas to make really good chocolate chip cookies.
Tell me more.
So if you don't like the taste of them, or if you're on the space station and you really need to stretch that legume and make a ton of different things out of that one ingredient, then, getting creative and using recipes like this is kind of what we do. And so I'm excited to help you guys out. I want to share some pictures with you guys. Let me see. So here is this is the I don't know if that's coming through. This is the food that we serve at Leguminaut. This is our crunch wrap.
Yeah, not yet.
So it looks kind of like a Taco Bell crunch wrap with a tortilla, and inside it you can see it looks like there's ground beef.
I can't see it.
That's actually made from soybeans that are made into like a textured vegetable protein that we then season and turn into ground beef.
Beth, we can't see your screen.
Oh, is it not coming through?
No.
No.
I'm sorry.
Okay, down below there, you'll see a little.
All right, there we go.
On behalf of Space, I just want to say.
There we go. Okay, so now you can see it.
Anyway.
Oh, wow. Yep.
Yeah.
You can see it now.
Got it.
Okay. So this is you can see on there like the ground beef is actually soybean. It's not real. It's not animal protein. It's soy protein. So and then another thing I wanted to share is during the pandemic we have been making some food to donate to our healthcare workers. So that's just been a little project that we have been working on. And if you're not local and you can't order us for takeout, you can go to our website and donate to help out. And our donations are going to provide meals to our local healthcare workers. So that's just a project that we're passionate about, that we're doing in our spare time, including this, which is really exciting. And so, all right. So now I just want to talk about my recipe that I'm going to do today. I'm not going to cook live today. Maybe next time, or this recipe uses a blender, and so it would be really loud, and I just figured I would make it ahead of time. I also wanted to taste test it, make sure it was good. So I made it for dinner last night and it got rave reviews. So I'll go ahead and it's green pea pesto. And so you need a blender or a food processor. And then the ingredients can be really flexible, because I know a lot of us right now, we're trying to limit going to the store, and the stores don't have everything that we want. So this is the kind of recipe where you can be really flexible with the ingredients and what you have in your pantry. But you might not have a ton of fresh vegetables right now, and having peas in the freezer is a great way to like have that fresh taste. So that's, whereas other legumes don't have that flavor that green peas do. So I think this is gonna be like a fun one, very like springtime, bring us out of our hibernation, and just, really kind of freshen things up. So I'm gonna go ahead and share with you some pictures of the ingredients.
And are you going to be able to post like a step-by-step if we're going to try this?
Yeah, so I have right here.
And we're going to have a food sharing next week of what everyone prepared.
Okay, so is that coming through?
It sure is.
Okay, so this is an image of all the ingredients that I just took like a shot so that you can see all of the ingredients used. And so you have 1 cup of peas, salt, olive oil, lemon juice.
I did it once and it comes out on one of my videos.
Thank you, Sam. I've got a 5-year-old who's really fascinated by legumes. And I think he's gonna have his favorite and his opinions about which one he's gonna pick and vote for.
I love it.
So I have on there half a cup of cashews, but you might not have cashews in your pantry. You could use any kind of nut. I wouldn't use peanuts. Well, one, they're a legume, they're not a nut. But if you had almonds or pine nuts or walnuts, you could sub that as well. Garlic. And then I realized there's a little metal measuring cup on there that I didn't label, and that is nutritional yeast. In fact, I will stop screen sharing for a second because I brought my, so this is nutritional yeast. You may not have this in your pantry. If you are not vegan, this is very similar to Parmesan cheese. In fact, it like even looks like it comes in the, so if you were making it at home and you had, and you were making the vegan version of this and you had vegan Parmesan cheese, you could use that. Or nutritional yeast is what we use in our house. So whatever your Parmesan is. You could also leave it out and add a little bit more salt to the recipe. It's a really flexible recipe. You can kind of do whatever you want to it. But nutritional yeast is a really cool ingredient. It's made from the byproduct of molasses. And it's really, really nutrient dense. I feel like this would be a really good food to send to the space station. Like, it's not a legume, but I'm a big fan of nutritional yeast. So I think it needs to be in space. It's really, really high in protein, and it's a really good source of B12. And there aren't a lot of there aren't a lot of vegetable and plant-based and non-animal-based sources of B12. So it's a really sustainable way to get a vital nutrient. So most vegans have this in their pantry, and I'm trying to like get other people to get on the nutritionally. It tastes kind of like Parmesan cheese. It tastes like nutty and just really yummy and delicious, and it's really good for you. So I like to put on my popcorn. It's really good on popcorn. Yeah. So. But you don't have to have it in your pantry to make this recipe. And I don't want anybody going out to the store to get anything special. Do not go out to the store to get anything special for my recipes. You can order them online if you need to order groceries online, but don't go to the store just to make this recipe. Stay home. And so I will now show you guys this is the, so here is the finished pesto that we put on top of some pasta. And so all I did was
I think you need to share it.
Is it working?
No.
There we go.
There we go. Yep.
Okay, there we go. So yeah, so you take the peas and you're gonna put them in the blender. So you're gonna blend up those peas and all those other ingredients in the blender. And then while you're making your pasta, you're gonna get this creamy sauce, and then you're gonna pour it over the pasta, and then it's ready to eat. It takes less than 10 minutes to make. So this is a really, if you're, you've got some peas in the freezer, you don't know what to make for dinner, you don't have a ton of time, this is a really easy thing to do. And it's got protein from the peas, so it's a complete meal. It's really filling. I could barely finish mine. And I have a big appetite, so that was, it's a good dinner or lunch, and it's even good leftover cold. So it goes over really well. And so let me see. I have some right here. I do have some.
Oh, that's not fair.
For my 5-year-old for lunch today, so I had some leftover pesto. So I have some here, and it smells really good. I think it tastes just as good cold as it does hot. So it's one of those things where it's really good for leftovers, and it's just really easy to make. Some other things I like to do with peas. I like to make hummus with peas. I know hummus is usually made with chickpeas, but again, if you have a blender and you're making just like this pesto sauce, you can add peas to the blender with garlic and tahini, any hummus recipe, or you can take store-bought hummus and add peas to it and blend it up just to add some flavor and nutrition to your store-bought hummus, and it's really, really good. I've also done where I blend peas into a puree and I add it to my guacamole. It's, if you only have 1 or 2 avocados and you want to stretch your guacamole and make it a larger portion, you can add pureed peas to it. So that might be, you know, during the pandemic, might be hard for you to get avocados, or your grocery bill can't, depending on where you are in the world, avocados can be really expensive. And I love guacamole, so I like to sometimes add peas to it, and it actually I like it just as much, if not better, with the peas in it. So that's another fun one that I like to do. And then I also this is my son's favorite way to eat peas. These are like pea crisps that you can get at the grocery store, and again, like these utilize peas that have been dried and turned into a flour. So when you're thinking about bringing peas into space, it's not just going to be the peas in their whole form. They can be dried and turned into a flour. And so anything that you can use, you could make pasta, like if you're, or bread, or it probably wouldn't make like a big puffy bread. It would make like a flat, like a tortilla. But there's so many things that you could do with that pea flour. I know a lot of like athletes use pea protein in their shakes, like pea protein supplement. So it seems like such a simple food, but it's actually really, really diverse. So I definitely think it's one that should be considered.
Yeah.
Yeah.
I love it. That's fantastic. So Pisum sativum, I guess, is the Latin name for our garden pea. Do we have, I don't think we have someone supporting garden pea for this experiment. It is on our list.
Although I did float the idea previously, I was saying that it'd be great because you can just eat the whole like pod when it's young.
Right.
And the flowers are beautiful. Like
They
one
are.
of the reasons for growing them is to keep you sane, watching those beautiful flowers pop up, and then having to eat the pea fast so you get another flower form. It's brilliant.
Well, there you go. That's
Plant size is also very reasonable. It's not too big, like a kidney bean type plant.
I'd love to add that to the group of things that I'm growing right now. Beth, that was so awesome. And all I could think of is peas being my partner on Glycine Max. So I absolutely want to explore that whole idea of just, hey, peas. We eat hummus all the time. That was not even one I would have considered to actually put it in there. The flexibility of peas. Wow, that's an eye opener there. And peas, strangely enough, for little children is the one they don't care to eat. And I don't know what that is. Broccoli's the other one, I think. But for most of the children that I've had experiences across my life, they didn't want peas unless they were frozen. So I think that you've actually made it a whole lot more exciting for us to eat peas. Thank you.
Well, thank you. Yeah, that's why I love these for the little kids, because they are getting the peas, but they taste so good. And so I don't feel so guilty giving those to my 5-year-old. Actually loves eating pea. He's one of those, strange ones that he really loves peas. He will eat them frozen too. It's so weird, but yeah,
those snap peas, I remember buying them for the first time when they came to Canada, and they look beautiful on the package. And when I opened them up, I saw these fuzzy little hairy things. And I went, whoa, I'm not sure that I want to eat that. And then afterwards, I got used to it, and they're actually quite good. It's like a chip. It tastes like a chip.
They're really good. They're good to, they're good for dipping too. One thing that if you're growing peas at home that a lot of people don't realize is that the frozen peas, like if you're using my recipe and you're adding frozen peas, those are already cooked. So if you've got fresh peas out of the garden, a lot of people think peas don't take a long time to cook, and they don't take a terribly long time to cook, but you do want to boil them for a good 8 minutes, because you want to get those starches to turn into sugars to make the peas really nice and sweet. So if you're growing your peas, you're going to want to do something called blanching, which is a technique where you boil something, and then after it's done cooking, so you're going to boil it for 8 minutes, then you're going to take that, drain it like you would pasta, like in a colander, and you're going to put those peas in ice water. And that ice water is going to stop the cooking. It's going to tell, the heat is going to stop, and you're going to keep that green color. So these peas have been blanched, so they're not like an ugly grayish green. And that's that we eat with our eyes. So we want our peas to be green and not like canned peas that kind of get like mushy and so doing that by blanching them and putting the cold water on them, that's how you keep them that bright, fresh green color. So not as important for other legumes, but peas are going to be one that you're going to want to do that with. The other ones aren't going to be as colorful, but that is one of the reasons I like peas, because they do have that pretty green color.
No, I'm very interested in the chemistry behind that as we think about what you've done to create those sugars through boiling, and now you're cooling down the experiment, right?
Right.
And that's just a little bit of science here in the kitchen. Things like measuring. If we have some young kids at home, this is your science lab, is your kitchen, right? And
exactly.
In our future episodes that we do find you in the kitchen, we can walk through some of those things about measuring, what have you, for our younger students, and even for those.
I would love if some students want to experiment and send me a recipe, or say, hey, I tried doing something else with peas. That would be awesome. Right. So play with your food and call it science. And because it would be cool to maybe blanch some peas and then take some and not blanch them and see what the difference is in their taste and their color, and just kind of experiment with that. So that would be a really cool kind of project.
I love it. So that is the Leguminaut challenge. Anyone that wants to do that, take over the next week, grab your peas, think about using Beth's recipe there, or maybe doing a variation. But why don't you share next week, if you can, if you're interested, anyone that's listening in, what you might do with your peas. And I guess you've got some more recipes in mind for us as well, right?
Oh yeah. And then if anybody has a favorite legume and they have an idea for a recipe, you feel free to share. I'd love to try out some other people's recipes as well. I have ones in mind for every single legume already, just because I'm excited. So I have a little notebook already with alfalfa and lentils and my little legume journal that I've already started, but I'd love to add to it. Maybe by the end we'll have a legume cookbook with a ton of ideas.
Yes, let's do it. Legume for Space cookbook.
Well, I think Lori Waters is one of our teachers. And Lori, do you want to talk about the project you gave to your students?
Right. So my students had to look at the nutritional value of the legumes in general, and then specifically their chosen legume, and then find a recipe. One of my students, she wasn't able to join us live today, but she might be watching through YouTube as she's working on another class. But they have a family recipe for, I think it's a lentil recipe. So I'll see if she'd be willing to share it. But they had to explore and look at the food options. And there were a wide range of choices, from soups to sauces to soy burgers. So they came up with some creative ideas. So I'll have to put them on the list for you and share them. Oh my.
Awesome.
Awesome.
That's Great.
Very
Now,
cool.
looks like if I remember correctly, Ruby, you were also with Lori's class, right? It's good to see you. I think I remember you from last time. Did you have any? We heard from your some of your other colleagues about what they were working on. Do you have something you want to share about your experiment? We'd love to hear it.
It's basically like what we've been doing, like how we were looking up like the nutrition values and like what's unique about each legume, and basically like mostly like what we can do with it and how far we can go. Yeah, we've gone to like find what impressed me the most is that with the amount of protein that they have, they can actually like replace meat. So a recipe that I found was like a lentil burger. So that's what I found like really cool about it.
Have you
That
tried
sounds
to make
really
one yet?
good.
Have you tried to make a lentil burger yet?
I love lentil burgers. They're really, I've also made lentil meatballs. So like spaghetti and meatballs, and the burger you can take and like roll into a ball and have a lentil meatball, and they're really, really good. Lentils are another favorite of mine because they're
I see Steve
so.
taking notes there.
Yeah.
He's our lentil king.
Yeah, lentils are awesome. You can
There
do
you
a
go.
lot with them. Lori, I think that we have a mutual friend, Janelle Culverwell.
Yes.
You looked so familiar, and I was like, I know you. That's so funny.
Yes.
Yeah.
Absolutely. I was trying to remember if I had been to the restaurant or not, because Janelle and I had lunch at one point over on that side of town. So, but when all this is over, I definitely have to come visit.
Absolutely. Absolutely.
You
There's a
have to
crunch
go,
wrap with your
apparently.
name on it. Yeah.
Yeah. We'll have to do a student field trip to the restaurant.
I think so. I think so. Yeah.
And I really like this idea of a recipe book. So let's
I
open
love
it.
it.
Does someone have a recipe they want to share? Let's compile it. Let's put together, whether we share it here in a video chat on Fridays or you just sharing it in our community. Let's put together something. It'd be a lot of fun.
Yeah, I think that would be fun.
You know,
And
space.
Ted, I'm working on with C formulating that lesson in a way to put it up within the Leguminaut challenge, so that if other teachers want to model that aspect of it, and you can level it, you know, for even elementary, middle, or high, getting more into the research aspect if you're on the high school side. But definitely, I think it's a way to hook students in and realize that this is not just some big like unreachable science concept. It's applicable. And from my session this morning with Scott, he really emphasized that psychological impact of the astronauts eating fresh foods, that fruits and vegetables. They would celebrate when those cargo ships would arrive with the fresh foods on them. And so being able to not eat something that's in this, you know, warmed up packet, but something fresh is not only a nutritional benefit, but a mental health benefit. And I think that's also showing us through this quarantine, right? We find some mental joy in the food that we're eating. And so I think this is a great time to experiment with recipes with kids.
Awesome. Yeah,
I love the idea, Ted. I think it's great, Lori and Beth again and everybody else. And that's a really super idea that even the students right now can actually get involved in preparing some lessons. So I'm going to take it out to my students. I'm going to put it out there and say, hey, listen, what are you making in your kitchens right now? If we're going to be advocating, and we are advocating for glycine max, and here's what we're going to do. Take a look at what we actually do there. I hear Michael clearing his throat. Are you okay, Mike? But in the long run, love the idea and putting it together as a Magnitude 2.0 they call that a publication would be absolutely cool and make it free and accessible to people.
I'd like to say from like the researcher's perspective, I think that'd be a great idea. One of the things you see a lot in college is students that get there to do experiments and they're excited, but they're not great at writing it down. And it's just like a good recipe in the kitchen. When you go in there and you cook a meal, and if you're following the recipe really precise, and you get all the flavor, umami, all that good stuff, if you write down the recipe really in a really detailed way, recording the most crucial bits of information, you can get that flavor sensation again. You can eat that same meal again. And practicing that mechanism of recording it, getting your like lab book out, getting your recipe book out, and writing it down, drawing pictures, recording where you found the ingredients, you know, all these little details. Like, practicing that is really important holistically in life. So
Now, if we could just figure out a way to record smell.
Well, it's got to talk to the honeybee. My goodness. Those receptors.
Richard, we had some children in kindergarten who drew the entire process because, of course, their writing wasn't quite where it was at, but they drew everything they saw. And so their parents were then responsible for the backside of that, what the recipe was. And then we published a picture with the child and the parent, and they got to dress up and hold their spoons in the air and stuff like that. So it's so wide open. Like, it's great. It's great. Let's do this.
Can I can't make black eyed peas without some bacon though.
Soybean.
What's great is we are able to replicate the flavor of bacon using plants. That will really blow people's minds. That's what we specialize in doing, is taking those animal ingredients that people are so used to and replicating them, thinking like a scientist and saying, okay, this might have saturated fat, it might have protein, its bacon is smoked, so we're gonna, what things are gonna create that flavor, and how can we combine that to make the taste of bacon without the animal, so that it's more sustainable if we're gonna, bring it to space or have it, be environmentally friendly. So
Well,
that's something
I'd love to try that and see how that works in my beans.
Right.
Yeah. But
I will do that with the black eyed peas. I will do a bacon black eyed pea challenge accepted.
Okay. All right. It's got to be good and spicy though. You got to start with
I'm with you on that. Yeah.
Ted, can I put a little plug in your mind, because I'm going to have to go.
Okay.
When and if we get out there and be with society, because it will happen at some point, that I think we need to have a Magnitude.io ExoLab conference at Beth's restaurant. I'm just putting that out there.
Well, of course, that with the rocket launch.
Yes, that would be great.
Yeah.
I would pay to go there to do that. I have to go join another meeting across Canada right now. So I will see you guys later. If I can chime back in, I will. Love you all, folks. Students, as always, you're the awesomest.
Yeah.
Beantastic.
Beantastic. Have a beantastic weekend, folks.
Yeah. All right, Dana, good to see you. We're going to segue over to Michael, and he's going to help us understand. We're going to run a laboratory experiment and keep everything clean. How do you do it? And I guess we're learning about that just with this pandemic, but
at least I don't have to go over how to wash your hands. That's a first.
Yeah. It's all yours, Michael.
Okay. So I just coming in a little late, but it sounds like it was a great conversation going. I just finished up with my
Dr. Barker's halfway through his journey talking about the connection between Rhizobia and our.
Oh, that was so awesome.
It was killing me to have to sign off on that, Richard. It was just like
part two is coming up here a little later.
Yeah.
Richard, that was so great.
The completed model. This is I'm sure many of you can relate. I know Tony can. I got Christine again. So my wife is a therapist, and she's running sessions in the office. So I had to come out here and quickly. So I've got like planks set up instead of my desk and everything. So this will be a little bit rougher than it might have otherwise been, but it's COVID-19. I'm going to switch to the computer mics. I don't get tangled up in my headphones. One moment. Okay, y'all hear me now?
Yep.
So just like there are lots of experiments that you want to contain what's in the experiment from the environment, and likewise contain the experiment from the environment, right? You don't want crossover sometimes. And on these labs that we're doing, we've got all kinds of wild organisms that are floating around in the air. They're on us, on our clothes, everything. So it can be really challenging, especially when you're working with the tissue culture media that some of us are for our growth media. Just everything loves to grow on that. That's why, that's why they created those recipes, is because stuff grows really well on it. Problem is we end up with molds and mildews and yeast and all kinds of things that can interfere with our experiment. So it's if you don't want your experiment to get out into your environment, or you don't want your environment to get into your experiment, one way of dealing with this in a laboratory would be a laminar flow hood, but I don't think most of us have that at home because it's kind of expensive and takes up a lot of space. But you can make a glove box, and you can actually give it a negative airflow by installing a little tiny fan in it if you want. And I'll talk some more about those specifics. But it's just a trip to your Home Depot or Lowe's or hardware store. You are going to need a couple of hardware supplies, so it's easier to, I think, to do that. The best time to buy these containers is actually at the times that college students are moving in or out, because every place puts these on crazy sales. I think I paid $5 for this one. It's a Sterilite, and it's a I think it's a, what is it? 10 liter, 15 liter, something like that. So it's pretty sizable, but it's perfect size for most of the experiments. So you'll need a box, however big or small you want. You will need some weather stripping, and this is a self-adhesive one. You'll need some gloves. I found these on Amazon. They've got a really nice long cuff, and they're really tough. They've got a nice grip on them. And I think I got 2 pair for like, I don't know, $15 or something like that. They were not expensive at all, but there's real good grip with them. I can almost snap my fingers.
Snap those fingers.
They're really tough. Nothing's going to get through those, and they should last a long time. The other thing you're going to need is a visit to the plumbing aisle, and you want something that's called a closet flange. And for those that
toilet,
this is what your toilet mounts on. This goes into the floor, into the pipe to the sewer, and then your toilet gets mounted onto this. So you need 2 of these. Okay, and they're pretty inexpensive. You can get them in plastic or metal. I chose the plastic, just it's a little cleaner to work with. If you want to have power to your glove box, or you want to install a fan, something like that, these grommets that go on desks, and there's just a little punch out here so that the cord can go through, and you mount this on the wall, probably the back or side wall of your glove box, if you want to do that. That's a good sturdy utility knife, and a little bit of time and patience. That's really all this takes. So because the cutting does take time, I didn't want to bore you all with me scoring and going through. I've gone ahead and pre-cut these, and I'm going to disassemble the partial assembly that I did. So we'll go from step 1. And step 1 is, of course, deciding where you want your holes to be. You want to have them about shoulder width apart, so you can kind of see where the holes are. They're right at my shoulders, and down fairly low on the glove box. But you want to make sure that however big your box is, that you can reach through, when you put your hands through the hole, that you can pretty much reach the entire space. So I can get that corner, I can get this corner. It's kind of like a windshield wiper. I can't quite get this back corner or this back corner. So those are dead spaces. There's not much you can do about that. You are going to have some dead space. If this is for students, you might want to put them a little closer together. And then think about, the surface that you're going to be using, so that it's fairly low is better, because then you can really see, and you've got plenty of height to get your hands around and over things. So you do have to think about limited mobility, which is also great if you're if you're trying to simulate something on the space station. This is a great way to give kids that kind of an experience, because they've got those heavy gloves, limited mobility. They can't just you know, they've got to work with that space.
Random factoid about that.
Place on your on the side that you want in the position. Take a Sharpie and trace the outline of it. I recommend you do the inside and the outside of it because there's a thickness to this. This is about the wall of this one's about 4 millimeters. So I want to make sure that I leave plenty of room for that. I want it to be a snug fit. So I actually undercut mine, and then I go through. Oh, then I go back with my utility knife and just carefully whittle away with the plastic to get a better fit. So just really, you know, the thinnest little shavings that you can get. So it takes a little bit of time. You want to give yourself about, half hour, 40 minutes to cut the holes, because if you rush, you'll end up cracking your plastic. I don't know if you can see that crack. And if the crack's too big, then you've lost your container and you're gonna have to start over. This one I know will fit behind the closet flange, so it's gonna be okay. And I can put a little bit of silicone sealant on that crack to prevent any kind of transfer of gases. So that's not gonna be a problem. Questions so far?
I got a funny comment. So the company that makes the spacesuits, the astronauts do spacewalks in.
Theoretically unmuted, but
so
my volume's muted. Try again, Richard.
Oh, we can hear you.
Yeah, it was on my end.
So the astronauts, the company that makes the spacesuits for the astronauts is the same company, the world's biggest company for making those protective gloves for like high tech like laboratories where they do like dangerous virus work and human pathogen work. So like the amount of movement that an astronaut has when he's doing like a spacewalk is the same amount of movement that you get when you have your hands in these flow hood things. So when you're practicing in them, you're practicing the same techniques that the astronauts practice when they're going to be training to do spacewalks. And by building this, you're practicing the same skills that are used at MIT in their spacesuit development laboratory as they try and push the boundaries for the future generation of spacewalk outfits, spacesuits. And so this is good training for those like NASA programs direct. Hey, Kenny, keep going.
No, I totally agree, Richard. And also you were talking about the following directions and everything earlier. This is a great activity to really think through both the building of it, but the use of it. You've really got to think through how are you going to set up your experiment, and I'll get to that in a couple of minutes if I still have some time. So the next step is we can actually install the gloves, and you got to think left glove goes in the left hole and right glove goes in the right hole. And which way do you want the thumb to be pointed? Okay, so it's a little bit of thinking before you install it. Everything is dry fit at first so that you have plenty of room for mistakes, because once you've screwed things in or glued things in, you're kind of stuck. So the way I've found works best is I just slide the cuff of the glove up here and get a little bit of extra, not much, so that the glove actually creates a seal between the closet flange and the side of the container. And I found that I like my thumb to be pointed at about 1 o'clock for my neutral position. So that's how I position my glove as I enter it into the hole. All right, I just slide that down. I'm gonna move my screen a little bit so it's a little easier for you to see. Okay, and then gently, because I don't want to tear the glove. This is, again, it's gonna be a tight fit. I've got to kind of navigate this through, and I want to check it as I'm going to make sure that I've got even distribution of the glove. Check my position. I turned a little bit thumb a little too far, and then go ahead and press it all the way down, supporting it from the back so you don't break your crack the plastic. Okay, and that's a good. And then test it. Make sure that that feels right, and that's exactly where I want it. There's that windshield wiper. I've got half of the box, I can easily cover with that one hand. It's a good resting position for me. That's really comfortable. That's kind of just naturally how my hands rest. And so that's the deal. This will function for the classroom, you know, as is. You don't have to go any further, really. But I do like to drill holes and put a little bolt in there. Gives a little bit of reinforcement. And I also then like to run a bead of that silicone caulk around to get a really tight seal. Make sure I don't have any gas exchange. And then repeat the step with my right glove. Slide the cuff onto the closet flange. A little bit of extra. Make sure my thumb's pointing at about 1 o'clock. Glove through the hole. Slide it all down in. Double check alignment. Okay. And there we go.
Awesome. Good deal.
Now, the other issue is if you don't fasten these down, it's harder to get out of them, because ideally what you want to do is you're going to pull the glove out as you remove your hand, because that makes it a whole lot easier to put the glove back on when you go into it. So with this bolted down, if I don't bolt it down, it can kind of pull it out. You can see it's lifting up off of the surface. Okay, and that also keeps them clear when you clean and reset your glove box. Okay, so I've got my gloves in their resting position. Take this off. Now I've got to create my base. And again, I want a nice tight seal. So you can buy this weather stripping. This is about 1 centimeter in diameter. So is that like 3/8, I think? And I want to put this down as a bead right along the part that's going to contact the lip of the container. This is pretty handy because it's self-stick. And I'm just going to start here. It's best to not start on a corner or on the middle of a straight, like where the handle is. Those are high stress areas, and if you've got a joint there, it's going to more likely come loose. Take your time so you've got it placed exactly where you want it, so you don't reduce the stickiness of the adhesive. Okay, work that corner, keep it nice and tight through the corner. The nice thing about this is so flexible that it goes around easily around these corners without kinking. It follows the contours of the molding of the plastic. When you choose your storage tub, go for the ones that have the highest optical clarity. It's surprising. This isn't perfectly transparent, but it's surprisingly more than adequate. And the ones that are totally clear the plastics tend to be a little more rigid, which makes it a little more difficult to cut the holes by hand without cracking things. If you're a hobbyist, you might have a Dremel tool. That can be a really slick way to cut the holes. I would not use a jigsaw because that up and down motion of the jigsaw for the thickness of your material, and it's too much flex, you can really just wreck your box. You're not going to end up with a very good product at the end, and you might even just completely destroy the box.
What I did, Michael, while you're building this is I just sharing a few images from the space station glove box. So you can see.
If you're really ambitious, you could always cut out a panel, like the top panel, or the front of your glove box with this kind of a box, and then mount a piece of plexiglass or acrylic in there. So I'm just going to cut my weather stripping. It'll be easier with the scissor. Make sure I got that tight. Okay. It fits on, clamps tight. Now I've got my experiment ready to go. So when it's in use, the way I set it up is I put my base down. I place an absorbent chuck just to kind of contain any spills. Looks like this one I could probably cut. This is a big one. A smaller one would probably be better, but this is what I grabbed. So you can cut it to fit or fold it to fit, whatever's most convenient. All right, so you get the idea that way. I'm not going to waste the clean side and the absorbent side, so I'm just going to fold it back up and place the parts of my experiment on here for demo. You don't have to do that. You could put, if you don't have a chuck, you could just use paper towels or just not worry about it. There is a little bit of a ridge here. So it will contain some small spills, at least on this particular design. Wipe everything down with a Clorox wipe or some alcohol and a paper towel so that it's good and clean. Let it air dry. I'm going to put my chuck there. I'm going to put my experiment here. I'm going to be transplanting. So I've got to think about everything, and everything I'm putting in here obviously is clean. Otherwise, what was the point? The tools that I need, again, you really got to think ahead of what the job is you're doing. What materials will it require? Okay. So that's basically what I'm going to need, because what I'm going to do is and I really don't need this, so put that one away. The less you put in here, the better. The foil is just keeping this dark, so I don't need that. I'm going to remove that. That'll be one less thing in my way. Okay. And that's about, I think, everything I need. So I put my top on. Gloves on. Okay. Set these up a little further so I don't bump into them. I'm going to remove that paper towel. Okay, and there's my mung bean seedling, perfect radical length for planting. So I'm going to take my spatula, make a small hole in these film canisters. You can go back and review the history of this item. A film canister? What's he talking about? So I'm making a small hole that's about 1 centimeter or so deep so that my my seed has a place to go. The potting media that I'm using here is an equal parts sand, vermiculite, and coffee grounds. My mung bean, radical down. Just gently work it in because I don't want to break the radical or the cotyledons. I don't really have to cover it. So it's just slightly done. And je suis fini. And again, this is hard to get out because I don't have my closet flanges fastened down, but it really is quite easy to pull out. That's it. So it's a really easy build. As long as you can safely handle a utility knife or an X-Acto knife, you can do this. So 5th grade and up, I know 4th graders sometimes get a little, if they wear if they wore work gloves to protect them, if it slips, that might be okay, leather gloves. But as a kid, I was always whittling and stuff, so I got scars all over my hands. So, you know, use your judgment on whether or not your child is old enough to do this, or your students are old enough. But it is, you can see it's a pretty simple build. The thing that takes the most time is cutting the holes. And you really want to take your time there. I know you're going to want to rush because you're excited and you want to have your glove box done. But the minute you start rushing on those cuts, then you end up destroying your container, or you get holes that they're not circular, and then you can't get a tight seal. And then what was the point? If it's, as teachers, you know, make your first one. It's not for contamination issues. It's just for like getting that experience of working in space. So maybe you're going to have kids build Lego models or something in it with the gloves on. So that's really it. And if questions,
it gives me an idea. So I've recently been doing a bit of art where I like carve plastic with like a hot blade.
Yes.
And I can't help but wonder, again, these things, you have to be cautious of your students because these things are hot. Don't burn yourself. They give off fumes. Don't do it in a enclosed environment. But I guess it might be easier. What do you think?
Yeah, it's a little bit easier. That's, if you look at the end of this blade, it actually is tempered because I had a candle and I would heat the blade up. This kind of knife, the blade doesn't stay hot long enough to really accomplish much. And then with the hot blade, it actually sticks as soon as it cools off. So you need a pretty solid blade that's going to hold the heat. If you're using it, something that you're heating with like a candle or a burner or something. If you've got one of those electric ones, that's the nichrome wire ones. That's a really slick way. You obviously have to get some holes started, but that's easy enough to do with a drill or even the end of an X-Acto knife, or a scissor. You just kind of wiggle it back and forth and slowly cut that hole. If somebody's in a woodworker's family and you got a hole saw that's the right size for the closet flange, go with that. Put it on the end of the drill and you'll have a nice clean hole. But cut slowly. You still want to cut slowly.
Awesome. Hey, Tony, maybe you can help me out. I pinned Michael during this because I had some problems with the mic and it was popping around, but I can't seem to unpin Mike. So he's the center of the, which is great, especially but we want to segue over to Michael. Thank you so much. I'm ready to build a glove box for sure. But we want to now move our programming over to En Español with Javier and some students from Mexico Tech. Monterrey Tech. And so Javier, maybe a little introduction to what we're about to do. And Tony, I don't know if you can unpin Michael, or there you go. I guess it's set now. And Javier, it's welcome to our students from Monterrey Tech. Maybe a little background.
I'm sorry, I just want to interact. I've got one last class for the day, for the week. Okay. So I'm going to sign off. These broadcasts are so much fun. I hope people come back. There's so many wonderful ideas. I wish I could sit in the full time and didn't have to do double duty between my students and this broadcast. But please, if you got ideas, let us know. hello@Magnitude.io. And if you got questions or anything, I want to get in touch with one of us directly, please reach out and we will reach back.
Awesome.
Be well, everyone.
Thank you, Michael.
Okay, guys, well, thanks for having us again. And this is going to be a brief introduction in Spanish about what we're doing here. And I invited a group of students from Mexico. They are Maria Paula, Azucena, we have Regina, who else we have? Greg, don't see your name. Greg. Who else we have? Well, they're from Monterrey Tech, and I invited them because they are working in very interesting projects, and one of them is going to be Magnitude. David is going to lead this project in Mexico. I'm going to be helping these guys as well. And what is interesting about this is that this is a project for most of the students. they're coming from engineering background, and they are in the program of engineering of sustainability and development. And I was talking to them yesterday, and one interesting fact is that they really jumped on this, because it was very short notice, because we have a meeting, and they told me, hey, why don't you invite someone, you know, to speak about this project in Spanish. I talked to them and they immediately say yes. So I really appreciate your time and effort. In just probably a couple of hours, you made this presentation with your team all together, and I'm very happy that you're here with us. So as I was telling you, this is an opportunity for everybody, for every student. Not because you're working in engineering, that doesn't mean that you cannot do these kind of projects that are related to NASA, because NASA is a very diverse organization where just not only people with engineering background or research background are employed. We have different people working on this organization, and we invite people, you know, to work in this organization as well, because we need diverse background and diverse population, diverse knowledge, so that way we can tackle and solve the problems that we have in our world. And one of them is the Leguminaut Challenge. The Leguminaut Challenge is a project that, you know, pertains to everybody now, because we need to find different ways to make sustainability in Earth as well, based on research in space. So this is something that we're gonna try to work more a little bit in Monterey Tech. And this is just a welcome to our students as well. And one of the things that I really, really enjoy about my job is that I can work with a very range group of students. I work with kindergarten students and with these kind of guys in the engineering program. So thank you everybody for joining us, and we're gonna switch now to Spanish. Anything else, Ted or Tony?
Gracias.
Pues bueno, muchísimas gracias. Vamos a hablar ahora en español. Voy a dar una pequeña y breve introducción sobre lo que es el programa Leguminaut. El programa Leguminauta es un programa que fue generado en Magnitude, y estamos teniendo esta sesión porque tenemos diferentes personas en diferentes partes de países de habla hispana. Tenemos gente en España, en Perú, en México y creo que en Brasil, que no son españoles, hablan portugués, pero en fin, parece un poquito al español. Así es que voy a dar una pequeña introducción a lo que es el reto Leguminaut. Can you see my screen?
Looks great.
Okay.
We live on such a beautiful planet.
See you up there. Fertilize really not sustainable.
Stayed up 75 days and went around the world 6 times.
It's called Anpanma. So this is a superhero in Japan. When you go to Mars, you have to repurpose everything. And we're not talking about this alfalfa.
Legume is one of our top candidates for B1.
Imagine if you're on the station and you need food. What are you going to eat?
We use things like model organisms. Plants are model organisms.
Is this stimulus that we're constantly causing? What would that look like? Oh, isn't that such a fascinating thing?
So I think you could absolutely use mini-PCR in your classroom to amplify the 16S sequence.
Siempre nuestra salsa picante. Algo muy interesante que tenemos en la parte de atrás es que
space science, how all of these are interrelated, the physics, chemistry, biology.
And we have some worldwide presence. We have Bill from Saki, Japan, Shiva and Trisha from South Africa, Wilson and Anna here from Germany.
Bueno, el objetivo del reto Leguminauta es proveer a los estudiantes con todas aquellas habilidades necesarias para hacer investigación científica, y eso surgió por la pandemia, ¿no? Nosotros tenemos este reto de enseñar a los estudiantes ese tipo de habilidades de manera remota. Entonces es una oportunidad y un reto para nosotros como profesores bilingües y sobre todo profesores en Latinoamérica y países de habla hispana, en donde no tenemos muchas veces los recursos y la capacidad que se tiene, por ejemplo, aquí en Texas o en California o en otros lados. Pero el reto de nosotros es cómo enseñar ese tipo de habilidades utilizando los recursos necesarios que tenemos en nuestros países para proveer esta capacidad a nuestros estudiantes. El reto Leguminauta trata sobre semillas que se van a mandar al espacio. El reto es saber cuál se va a mandar y el reto de nosotros consiste en estudiantes desde prekinder hasta universitarios o grados más avanzados y vamos a hacer investigación de acuerdo a las capacidades de cada estudiante. Por ejemplo, nosotros estamos en un grupo donde estamos trabajando con alrededor de 6 profesores bilingües ahorita. Estoy trabajando ahorita con un profesor en México, de hecho ahorita está conectado el profesor Max. En Kinder nosotros ya estamos por terminar este proyecto. Con el profesor Max estamos por iniciar, pero la diferencia va a ser el nivel educativo de cada estudiante. Nosotros en Kinder solamente es investigar, hacer alguna sesión de prueba, pero por ejemplo con el profesor en México vamos a hacer esto una experiencia de realidad virtual para que los estudiantes no solamente propongan cuál es la semilla, sino cómo se vería la semilla en el espacio, cómo se vería en un entorno más a un futuro. Entonces, como les digo, se consiste en el reto de cada estudiante. Les voy a hablar un poquito sobre qué es Magnitude para las personas que todavía no saben qué es Magnitude. Magnitude es una compañía que está en California y se dedica a hacer experiencias educativas aeroespaciales. Una de ellas es el ExoLab. El ExoLab es una caja que pudieron ver al principio de la presentación, en donde por medio de telemetría y sensores se pueden hacer investigaciones en la Tierra. Esta caja está conectada a diferentes cajas alrededor del mundo y también tenemos una caja hermana a bordo de la Estación Espacial Internacional, en donde también por medio de telemetría y sensores se puede hacer investigación y comparar las dos muestras, una muestra en el espacio y una muestra en la Tierra, y se pueden comparar los diferentes sensores y las diferentes cámaras para ver cómo se desarrolla una planta tanto en la Tierra como en el espacio. Tienen otra proyecto muy interesante que también lo vimos al principio de la presentación, que fue el de globos aerostáticos con sensores. Estos globos son una especie de satélite. Tienen de hecho 2 modelos, uno que es un modelo pequeño que sirve para trazar y también se tiene otro más grande que se llama payload. Payload es una carga que se manda a la estratosfera y se ponen diferentes experimentos a bordo de la caja para ver cómo reaccionan los experimentos a en diferentes capas de la atmósfera y estratosfera. El reto de Leguminauta es una oportunidad para que los estudiantes nos ayuden a decidir cuál es la planta que crecerá a bordo de la Estación Espacial Internacional. Y esto se va a hacer en este reto que se llama ExoLab 8. Al principio del año, Ted nos comentaba que ahorita las fechas están un poco indecisas porque por medio de la pandemia teníamos diferentes fechas de cortes para hacer las investigaciones. Se planeaba hacerlas para octubre, después para noviembre, ahorita se pospuso para febrero. Y estas fechas vamos a tratar de confirmarlas bien para hacérselas llevar y que sus estudiantes asuman este reto. Actualmente se están investigando estas plantas porque juegan un ciclo muy importante en la exploración espacial. Como saben, llevar una carga al espacio es muy cara, necesitan mucho espacio en una nave para llevarla, pero una semilla es muy pequeña, se reproduce y puede duplicar, triplicar, quintuplicar el tamaño en muy pequeño tiempo. También se está haciendo este reto para ver cuál es el efecto de una bacteria que se llama Rhizobium. Rhizobium es una bacteria que infecta a las raíces, pero es una relación de simbiosis en donde la raíz y la bacteria producen nitrógeno para poder fijar más niveles de nutrición hacia las plantas. La misión del reto es poder elegir entre alfalfa, caupí, trébol rojo, soya, atsuki, garbanzos, lentejas, frijol, mungo o chícharos, pero también, como Ted lo comentaba al principio, no porque estemos proponiendo nosotros estas plantas, podamos dejar una planta fuera. Recuerden que la misión del reto de nosotros es que los estudiantes puedan adquirir habilidades de investigación en campo y de investigación científica a diferentes niveles. Y si, por ejemplo, se tienen otras plantas que sean nativas de algún país, nos gustaría ver cuál es esa planta para también nosotros poderla tratar de incluirla en algún futuro. Se decidieron estas semillas porque son más comunes a todo mundo y son las que tienen mayor probabilidad de incluirse en la investigación aeroespacial. Pero recuerden, pueden ustedes también incluir la suya siempre y cuando sea respaldada por una investigación científica. La misión del reto es que puedan formar y fomentar la creatividad en los estudiantes. Se pueden los estudiantes hacer diferentes proyectos, ya sea de artísticos, ya sean de videos, ya sean carteles. Por ejemplo, con los estudiantes que estamos trabajando ahorita, vamos a hacer una serie de carteles en donde se culmine por medio de este cartel toda la investigación que se hizo durante 3 semanas. La leguminosa que con más apoyo que se tenga en este reto se va a lanzar en una nave de SpaceX, posiblemente sea la NG-15 en febrero del 2021. No tenemos la fecha exacta porque ya ha pasado en varias ocasiones que hay una fecha de lanzamiento, pero por el clima o por cualquier cosa administrativa, la fecha se mueve 1 o 2 días después. Los materiales que se tienen en la plataforma son multilingües. Los profesores pueden accesar a esta parte que es de manera gratuita. Se tienen 2 diferentes modalidades. La primera es el Leguminaut Challenge o el reto Leguminauta, en donde los estudiantes van a hacer una serie de retos para investigar y proponer la mejor planta en el espacio. Después de esto se termina la primera fase, después viene una segunda fase en donde los estudiantes necesitan tener un ExoLab en su salón de clases y si quieren investigar un poquito más a fondo, hacer una investigación un poquito más exhaustiva con los recursos que se tengan en las escuelas, necesitan tener una caja y esa caja sí tiene un precio. Pueden hablar con Teddy y Tony para que después les pueda decir cuál es el precio de la caja, pero no por eso no significa que no puedan hacer la primera parte del reto, que es un reto muy completo para todos los estudiantes. Esos materiales, como los decía, los tenemos en diferentes idiomas, están en inglés, en alemán, en español y en francés. Y como también les comentaba al principio, el objetivo de nosotros es fomentar la creatividad en los formatos que se planeen para los estudiantes. Puede ser algún video, algún TikTok, ahorita que está mucho de moda, proyectos en YouTube. proyectos de arte, excursiones virtuales, informes de laboratorio en Google Docs, en fin. El profesor tiene la capacidad de innovar porque no queremos solamente que se encierre en una lección, sino que también nos interesa que el profesor sea como un chef, ¿no? Que vaya poniendo de su cosecha, que vaya poniendo los ingredientes de tal manera que al nivel del profesor y al nivel del alumno, esto pueda ser un reto muy, muy interesante para los estudiantes. Ese es un ejemplo de lo que hicimos nosotros, el grupo de profesores. Ese es el reto para Kinder. Y como les decía, es muy diferente, ¿no? Cómo se ve este reto en material, perdón, para Kinder y en grados más avanzados. Ese se llama el programa Leguminauta. Lo que hicimos aquí fue hacer 8 retos por los tiempos que nosotros tenemos. De hecho, creo que hay un alumno aquí conectado haciendo el último reto. Y esto fue algo muy pensado para que los estudiantes tengan un proceso de aprendizaje que aquí en Estados Unidos le llamamos blended learning. Blended learning es una modalidad en el que el estudiante recibe instrucciones por medio de videos o por medio de videoconferencias, y en su casa puede el alumno generar algún artículo o algún producto, ya sea manual o escrito, en donde plasme lo que han aprendido durante la sesión. Por ejemplo, este fue un repaso del ciclo de vida de las plantas. Se tiene aquí un video y se tiene que revisar el video, y también se tiene un juego interactivo. Después de esto, los estudiantes van a ir haciendo una serie de dibujos y una serie de documentación durante cada reto. Estas son, por ejemplo, la misión número 2, las características físicas de las semillas. Estas habilidades de investigación en los estudiantes, se ha visto que a lo largo de la carrera donde ellos están, se les van olvidando, ¿no? Cuando van a segundo grado, tercer grado, ya no saben estas características. Y eso es algo muy importante porque para ser un investigador científico necesitas tú saber describir todas aquellas observaciones que tú tienes haciendo un estudio de laboratorio. Entonces, para nosotros es muy importante hacer esto de manera remedial, por medio de videos y por medio de prácticas en campo, ¿no? Que sería, por ejemplo, observar las semillas, describirlas, hacer un dibujo, en fin. Después de aquí se van a sembrar. Aquí tenemos el procedimiento de siembra, después se abre, en fin. Tenemos aquí todos estos retos. Y como les decía al final, el objetivo es hacer un cartel con los materiales que se tienen en casa, ¿no? También el objetivo de nosotros es fomentar la creatividad en los alumnos utilizando lo que se tiene en casa. ¿Cómo se ven las actividades, por ejemplo, para un grado de kinder? Se ven de diferentes maneras, ¿no? Los estudiantes están haciendo investigación, están tomando diferentes habilidades que apenas se les enseñó. Por ejemplo, están los niños apenas comenzando a medir, están viendo las plantas, están observando únicamente una variable, cómo se ve una planta con sol, una planta sin sol. Están haciendo sus dibujos, están documentando, en fin, están haciendo diferentes actividades durante estos 8 misiones. Estas son actividades que los estudiantes también han logrado hacer. Toman fotos, están dibujando, en fin. Es muy interesante para mí porque esto es algo que posiblemente lo podamos hacer en el salón, pero por medio de la pandemia pudiera ser a veces impensable, porque para enseñarle a un estudiante a describir una semilla o a describir unas plantas es un reto, ¿no? Pero por medio de este tipo de retos, se pueden realizar. Al final del reto Leguminaut les vamos a entregar un certificado de participación a los estudiantes con las misiones que han completado durante el ciclo del reto Leguminauta. Y ahora la pregunta para nosotros es, como profesor, si aceptas el reto, como les decía, es un reto que va a ir enfocado a las habilidades de cada estudiante y a las habilidades de cada profesor. Eso se va a ver de manera diferente en cada salón, con cada estudiante. Y es algo muy interesante porque a pesar de que es el mismo reto, es muy diverso, va a ser muy diverso y es en eso en lo que radica la riqueza de este proyecto. Any questions, guys? No?
Well, let's hear from some of your students.
Okay, now
what do you guys think?
Mayra, Gala.
Comparto pantalla con nuestra presentación.
Oh, okay, so they're about to start their presentation. And this is a presentation about how to start from the beginning. Because in Latin America, we started a little bit later. Because, you know, in the US and in other countries, you have your infrastructure already ready with your contacts with the ExoLabs in different parts of the country. But in Latin America, we don't have that. So we started a little bit late. So I talked to the team and I asked them, hey, what can we do in order for the teachers to train themselves and start from scratch? And this is a good opportunity for them to explore what they have learned from a previous conference they attended to. And also, it's interesting to see what these guys can offer based on their opportunities with the engineering background. So it's up to you guys.
Gracias. Gracias, Javier. Thank you very much.
Gracias.
Here. And we're going to talk about plant nutrition and some technologies. We will all be doing this in Spanish, and I hope you like it and learn. ¿Ven la presentación?
Sí.
Ok. Vamos a hablar sobre los mecanismos de crecimiento y tecnologías en organismos vegetales. Primero que nada, nos gustaría mencionar sobre la nutrición de las plantas, pero para eso es importante entender que las plantas llevan un ciclo de vida y en cada fase, cada etapa de su ciclo de vida llevan una diferente nutrición. La primera fase es la semilla. Hay dos tipos de semillas. Las angiospermas, que son las que están cubiertas, como una manzana, y las gimnospermas, que son las que están sueltas. En la etapa de las semillas es muy importante que haya un sustrato y una tierra muy bien nutrida y agua. En esta fase no es muy importante la luz del sol. Ahora, la semilla siempre va a estar muy dura al principio porque va a proteger, pero ya después, en la etapa de germinación, va a comenzar a ablandarse y va a empezar a crecer el tallo. En esta fase es importante también un buen sustrato, una buena nutrición. La luz del sol también es la que va a ayudar a guiar el tallo hacia arriba, una buena cantidad de agua y oxígeno. Después sigue el crecimiento de la planta, que es cuando ya empiezan a salir las primeras hojas. Y en esta etapa es muy importante porque es en la que empieza a ocurrir la fotosíntesis, que más adelante hablaré de eso. Y además las raíces empiezan a crecer y a extenderse por la tierra y a adherirse y a buscar nutrientes y agua para su supervivencia. Después sigue la etapa de reproducción. Hay dos tipos de reproducción, la asexual y la sexual. En esta etapa de reproducción podemos identificarla porque a las plantas les empiezan a crecer flores. En la etapa de reproducción sexual, los polinizadores como las abejas y las aves son muy importantes porque son los que transportan las semillas de un lado a otro y hay intercambio genético. En la reproducción asexual no hay intercambio genético porque literalmente la planta se reproduce a sí misma y es como si se clonara. Ahora sí vamos a hablar más sobre la fotosíntesis. En esta fase, la planta lo que hace es recibir la energía del sol o sea, literalmente absorbe los fotones de la luz del sol y eso los convierte en glucosa y oxígeno. En esta fase es muy importante porque la planta se nutre a sí misma y además ocurre la respiración celular. Literalmente aquí podemos ver la ecuación, el dióxido de carbono más agua más la fotosíntesis, más los fotones producen la glucosa y el oxígeno. El oxígeno lo usan para respirar y además el que no usaron lo avientan a la atmósfera. Literalmente por eso dicen que convierten dióxido de carbono en oxígeno, porque es lo que hacen.
Y bueno, yo soy Azucena Román y yo les voy a hablar acerca de los nutrientes necesarios para el desarrollo de las plantas. Se sabe que son 20 los elementos químicos que se han identificado en la mayor parte de las plantas. Sin embargo, solo 16 de estos son realmente necesarios para el desarrollo óptimo. Estos elementos se dividen en macronutrientes, que bueno, son los más importantes para el crecimiento y son suministrados por los fertilizantes. Y bueno, después están los mesonutrientes y micronutrientes u oligoelementos, los cuales se necesitan en dosis menores. Estos se presentan en el suelo, pero en cantidades pues menores, ya que son como en menor proporción y bueno, pero todo esto se abordará más adelante. Cada uno de los nutrientes tiene una función importante en el desarrollo de las plantas y ahora les hablaré acerca, bueno, a grandes rasgos, acerca de los elementos y cuál es como su función principal y cuáles son como las características o síntomas de deficiencia. El primer elemento es el nitrógeno, el cual estimula el crecimiento y favorece la síntesis de clorofila, aminoácidos y proteínas. Después, el fósforo, que ayuda a la formación de la semilla e influye en la síntesis y la respiración. Por otra parte, está el potasio, que su principal característica es aportar resistencia tanto al tallo como a prevenir enfermedades que entran al organismo. El calcio colabora con la división celular. El magnesio incorpora nutrientes y es un componente de la clorofila, las enzimas y las vitaminas. El azufre es el que aporta el color verde a las plantas y también ayuda a la formación de aminoácidos y de vitaminas. El boro es el elemento más importante porque es el que ayuda a la formación de las frutas y las flores. El cobre ayuda a la respiración y a la síntesis de clorofila. El cloro también ayuda a lo que es el crecimiento y en las raíces y a los brotes. El hierro es un catalizador en la formación de la clorofila. El manganeso también colabora con la síntesis de la clorofila. El molibdeno fija el nitrógeno, así como ayuda también a la síntesis de proteínas. Y por último, el zinc, que es el elemento esencial para la formación de auxina y almidón. Bueno, estos síntomas de deficiencia van desde el crecimiento atrofiado, las hojas quebradizas, marchitas o inclusive muertas, debilidad en el tallo y las hojas presentan color ya sea amarillento, verde clarito o verde azulado. Y bueno, dependiendo del elemento son los síntomas que van a presentar. Es importante mencionar que cada organismo interpreta los nutrientes de manera diferente y bueno, todo lo anterior fue de forma generalizada.
Bueno, buenas tardes. Mi nombre es Greg Garón y lo que sigue a la presentación acerca de los nutrientes es el origen de esos nutrientes, porque el suelo no tiene nutrientes en automático, sino que tienen una fuente. Esta fuente se puede dividir en dos. Puede ser la inorgánica o la orgánica. La inorgánica tiene que ver con la erosión que puede originar el aire o el agua, y se da erosionando las rocas. El aire y el agua, el viento y el agua, lo que hacen es transportar esos pequeños minerales que ya fueron arrancados de la roca madre, por así decirlo, y transportarlos a lugares más planos donde pueden asentarse de mejor manera. El ejemplo más claro es el delta del Nilo. El delta del Nilo fue por eso que se volvió tan fructífero, porque es un río larguísimo donde los minerales pudieron arrastrarse a través de muchos kilómetros y mucho tiempo, y la desembocadura fue una tierra sumamente fértil. Siguiente es el modo orgánico, que es el que necesita la vida. En este origen se necesita la descomposición celular. Como bien sabemos, los seres nacen, crecen, se reproducen y mueren. Al momento de morir, el cuerpo experimenta descomposición y va deteriorándose poco a poco. Esto, además de los gases que se generan, que no son recuperables, se van hacia la atmósfera, tiene ciertos compuestos que pueden ser aprovechados por el suelo, pero para eso hace falta intermediarios. ¿Cuáles son esos intermediarios? Los más importantes son todos animales pequeños, son todos organismos pequeños. Primero están los insectos y las lombrices, los cuales hacen de pedazos de materia orgánica grandes, pedazos pequeños. Los separan, por así decirlo, los desintegran de cierta manera para que después las bacterias y los hongos, en este caso podemos ver esta imagen, son las raíces de la planta de soya, y son pequeños nódulos que contienen a la bacteria conocida como Rhizobia, que es Rhizobium, del que habló Javier. Sí, y lo que hacen los hongos y las bacterias es desintegrar la materia orgánica a tal grado que su producto de desecho sean moléculas orgánicas que contienen nitrógeno, por ejemplo, el amoníaco, todo ese tipo de compuestos. Generalmente están hechos con los bioelementos principales, los compuestos esenciales para la vida, los elementos esenciales para la vida, que son el carbono, nitrógeno, oxígeno e hidrógeno. Y finalmente son aprovechados por la planta. Y ya.
Hola, buenas tardes a todos. Mi nombre es Gala Ochoa Rosales y voy a platicarles acerca del impacto de los factores ambientales en el crecimiento de un cultivo orgánico. Principalmente son 4 los que debemos considerar y, bueno, para empezar está el agua. Las plantas son 90% agua y es necesario que esté disponible en cantidades óptimas, no más, no menos, iniciando desde la germinación de la semilla y durante toda la vida de la planta. Pero debe de existir un equilibrio, ya que un estrés hídrico puede llevar al cultivo hasta la disección. Es cuando la planta cierra sus estomas, los cuales son pequeños poros en las hojas y tallos que permiten la salida de vapor de agua y la entrada de dióxido de carbono para así llevar a cabo la fotosíntesis, como explicó María Paula. La disección impide la absorción de dióxido de carbono, entonces pues la fotosíntesis no puede ser llevada a cabo y no se generan los azúcares necesarios, haciendo que se pierda la capacidad de sobrevivir de la planta conforme avance el tiempo. Para conservar la humedad necesaria se puede incorporar abonos verdes y enriquecer materia orgánica, como lo es la composta a partir de residuos orgánicos. Por otro lado, el lado contrario, la inundación de una planta genera el déficit de nitrógeno, que es un elemento esencial, como explicó mi compañera Azucena. Sin él no se puede promover el crecimiento de nuevos tallos, entonces la planta lleva a cabo su propia muerte. Entonces, para evitar estos extremos, se debe contar con un control de la frecuencia de hidratación a partir de controles tecnológicos o asegurar que contamos con un suelo favorecedor para el drenaje de agua en exceso. Como segundo factor está la luz, la cual es una variable fundamental. El crecimiento del cultivo está determinado, en primer lugar, por la cantidad de radiación solar que puede absorber y usar durante toda su vida. Un exceso de radiación solar raramente es un problema cuando hay agua y nutrientes disponibles para la planta. Luego, en número 3, está la calidad del suelo donde crecen los cultivos. Un suelo con textura porosa y un nivel homogéneo, así como que cuente con los nutrientes necesarios que ya explicamos anteriormente, ayuda a controlar el nivel hídrico y a nutrir a la planta, como explicó Greg. La estructura de la tierra debe ser favorable para que permita a las plantas jóvenes salir y tener un rápido acceso a los recursos vitales de los nutrientes, así como el agua, la aireación y la luz. Y de igual forma, si la salinidad del suelo no está equilibrado, la planta sufre alteraciones. Por ejemplo, cuando el pH está en extremos, algunos nutrientes están disponibles de manera excesiva que pueden llegar a ser tóxicos, mientras que otros no lo están. Entonces hay un desequilibrio. Y esta falta de equilibrio puede suceder debido a que el suelo tiene altos niveles de óxido de hierro y aluminio, o que hay una aplicación excesiva de fertilizantes y o materia orgánica del suelo. Y por último está la temperatura. La mayoría de las actividades biológicas ocurren en un rango de 10 a 30 grados centígrados. Esto se toma como referencia desde una planta de un invernadero. Y si las temperaturas son lo suficientemente bajas como para llegar a helar, puede producirse un daño severo en los tejidos jóvenes. Las temperaturas invernales por debajo del punto de congelación del agua, es decir, 0 grados centígrados, pueden matar la parte vegetativa. Por eso es muy importante controlar la temperatura. Cuando hay un desequilibrio y la temperatura es más alta, es decir, más caliente, el comportamiento de la planta puede, pues depende del nivel de hidratación con el que se cuente. Los cultivos con suficiente agua pueden soportar temperaturas del aire de hasta 40 grados centígrados. Pero si el agua es un factor limitante ahí, las hojas pueden morir a esa temperatura porque no pueden transpirar y se cierran los estomas, como ya habíamos mencionado. Y pues como la solución más sencilla, se recomienda regar en la noche para evitar la evaporación del agua y seleccionar el momento óptimo de siembra de tal manera que se eviten las temperaturas extremas. Y nada más quisimos incluir la gravedad porque es un factor a considerar por la naturaleza del crecimiento de la raíz que crece hacia abajo. Esto es debido a la presencia de gravitropismo, que es una modificación de la posición de las partes de la posición de las partes de una planta en respuesta a los diferentes estímulos gravitatorios. Y actualmente existen proyectos que investigan más a fondo estos efectos para ver si realmente se puede llevar el crecimiento de una planta hacia el espacio.
Hola, ¿qué tal? Yo soy Regina Cárdenas y bueno, yo voy a hablar sobre las diversas herramientas que existen capaces de facilitarnos la tarea de cultivar una planta con éxito. Todo esto se ha desarrollado a raíz del aumento de la población mundial. Para satisfacer las necesidades alimentarias, se busca cultivar más alimentos en menor tiempo. Y bueno, gracias a la tecnología, todo esto es posible. Por ejemplo, con un mejoramiento genético rápido, se puede acortar el ciclo de crecimiento de una planta y cosecharla más rápido. Un mes de cosecha se puede convertir en 2 semanas, en la mitad, por ejemplo. De igual manera, se puede modificar para que la planta sea resistente o por lo menos tolerante a malezas, a daños causados por plagas y enfermedades, a la sequía, al calor, al frío, a vientos o a otros factores negativos. También está el cultivo de tejidos vegetales, que consiste básicamente en cultivar en un medio artificial, no en tierra, puede ser en otra cosa, preparados químicos más bien. Una planta, se cultiva una planta a partir de un pedazo de otra. La importancia de este tipo de cultivo recae en la obtención de vegetales libres de patógenos y en la propagación masiva de plantas. Se puede lograr cultivar muchas plantas a partir de una sola. Y bueno, yo creo que se pueda crear una nueva planta a partir de un pedacito de otra genera muchas posibilidades. Bueno, esto es hablando de la planta, pero por otro lado, es posible monitorear y controlar las condiciones ambientales que ya mencionó mi compañera Gala, las cuales son esenciales para un buen desarrollo. Con sensores se puede medir la temperatura o la humedad para detectar una anomalía y así brindarle a las plantas lo que necesitan.
¿En qué contexto?
¿Qué dice? ¿Cuáles son las aportaciones?
También, si no existe un ambiente adecuado para cultivar, nosotros podemos crearlo con ayuda de la tecnología. Se puede controlar el clima para brindar calor, frío o la humedad necesaria. Y con iluminación LED mejorada, no es necesario depender de la luz solar, que aquí en la Tierra es de 12 horas o menos, pero no sé, en otros planetas. En Marte es más o menos lo mismo, pero quizá en otros lugares donde no hay suficiente luz, con focos LED se pueden tener periodos de luz de 22, de 24 horas todo el día para así optimizar la fotosíntesis y promover el crecimiento rápido de los cultivos.
Bueno, buenas tardes, yo soy Mayra Galván y ya para finalizar me gustaría hablarles sobre una alternativa tecnológica biodegradable que encontré y me pareció muy interesante. Y bueno, de acuerdo a la Organización de las Naciones Unidas para la Alimentación y la Agricultura, la FAO, en un informe del 2015, se menciona que aproximadamente un 33% de la tierra en el mundo se encuentra moderada o altamente degradada. Y esto es debido a factores como la erosión, la salinización, compactación, acidificación y también la contaminación química de los suelos, causada principalmente por el humano. En el concurso internacional llamado Desafío Global de Diseño de Biomímesis, un equipo chileno llamado BioNorth creó un prototipo que podría ayudar con esta problemática. Consiste básicamente en una base que es 100% biodegradable, como se observa en la imagen, y también de un cono. Ambas logran acobijar de una manera óptima plantas escogidas por la morfología de sus raíces, y de esa manera se logra restaurar biológicamente a suelos altamente compactados y degradados. La base se encuentra formada por, como se mencionó, material 100% orgánico y son especialmente tallos de maíz. Se acompaña con una capa de tierra y así se permite la aportación de los nutrientes y microbios necesarios para dirigir el agua hacia las raíces. El cono sirve principalmente como protección de la radiación solar y el viento. Bueno, esta composición se coloca sobre el suelo y de esa forma se logra la restauración del suelo. Existen 5 ventajas principales y se las voy a mencionar. La primera es la restauración del suelo. Al exponer las plántulas a una mezcla de nutrientes, se mejora la capacidad del suelo para retener agua, nutrientes y microorganismos. En segundo lugar, es un proyecto 100% inspirado en la naturaleza. Se tomó como fuente de inspiración a la yareta, que es una planta de cojines que lleva su ciclo en tierras degradadas y le da paso a nuevas especies de plantas y organismos para que vivan en simbiosis. Número 3, como ya se mencionó, es biodegradable y se aprovechan los desechos de tallo de maíz mientras no se genera basura. Número 4, es autosustentable, debido a que después de un año, las plantas que van creciendo ya son capaces de reproducirse y ser óptimas para el crecimiento de vida por sí solas. Y finalmente, 5, es económicamente rentable. El biopatch solo se usa una vez, que es al principio, y es una forma asequible y accesible para los agricultores para restaurar suelos. Y bueno, como ya mencionó Javier, son términos muy importantes para todos y el conocimiento de las plantas es algo sumamente fundamental. Conocer su ciclo de vida, los nutrientes, las variables que los afectan, nos ayudan a darnos una perspectiva más grande y completa sobre la importancia de las plantas en el planeta. Y sobre todo, nos da la importancia de cuidarlas y usarlas de una forma sustentable para el consumo humano. Este es un proyecto que nos pareció muy importante a todos y por eso decidimos formar parte, realizando esta pequeña aportación. Esperamos que les haya sido de su agrado. Somos estudiantes del Tecnológico de Monterrey, Campus Cuernavaca, en México. Y les mandamos muchos saludos. Muchas gracias.
Well, thank you very much. Gracias.
Thank you very much.
Marvelosas presentaciones. Very great presentation.
You got it.
Yeah. Ayudas a conectar el mundo. Right? You're connecting the world. And thank you so much. You know, the last presentation that you put together, the biopatch, I'm very curious of the mechanical there. Can maybe explain in English for me a little bit about the biopatch?
Yes. Okay. Sorry for my English, but I will try. So it was a team from Chile that created this biopatch that consists of a base is made from corn.
Okay.
And it is really important because it is 100% biodegradable, and also it's very accessible for the agricultures. And sorry, let me okay. Also, when you place the base on the ground, it needs to pass 1 year for it to be auto-sustainable, and the plants start to sorry, I got nervous. Well, it is a design that is inspired from nature, and I think that is a very great idea because it's zero waste. And I don't know, if you want, I can explain like slower in Spanish.
Fantastic. So, as I saw it, was it kind of similar to composting?
Yes.
This,
well,
is that correct? Am I thinking about it the right way? It's kind of like a compost pile, but you're growing your plants inside it?
Well, they use basically corn principally, but I didn't found like exactly how they made it, but it is 100% made from nature. Well, like a compost. And it's zero waste. That is the part that I like the most because, well, it is incredible. It gives life, and also it doesn't create waste.
That's fantastic. I enjoyed all the presentations. The overview of plant biology, photosynthesis, the technology you want to apply. We're really excited that you guys are interested in what we're doing, and we welcome you aboard. Let's find the right legume to send to space, okay? So gracias. Thank you very much. This is very exciting. I hope that you can join us in the subsequent weeks. We have, I think, 5 more weeks, at least 5 more weeks that we're doing this. And it's very encouraging to hear the voices around the world and our young, you are the future, right? As you're at university. And there's just so many things that are possible. We just need to make sure that you're given the tools to explore. And so thank you for sharing this. Yeah.
Do you know where hydroponics were invented?
Where were they invented?
Yeah, well, what we'd call Mexico these days. So like the Aztec Empire was founded on hydroponics. They just didn't call it then. They had rafts that looked quite like those corn rafts the previous student was teaching us about. And so they would float. They would build versions of that where they would seal the bottom, and then they would put the corn straight into that, and the roots would grow down into the rivers, and the shoots would grow up above. And because it was so hot and sunny and the corn was so efficient, like a civilization boomed. In fact, recent research has just shown there's a new place where agriculture arose. Like, so we often hear people talk about the Fertile Crescent in Mesopotamia, like Asia, Iran, Iraq, that kind of Middle Eastern area. You also sometimes hear of a period of agriculture rising around 10,000 years ago near the Indus Valley, a bit closer over to India. And then the Chinese scholars also documented around 10,000 years ago, just after like a cold age, there was a period when agriculture also independently arose in a place in China. So now recent evidence has shown it also happened in South America, northern Brazil, Bolivia, that kind of region at the foundation of the Amazon. There is a massive region there where like it's kind of like grassland, but then there's the occasional like small hill in this like flood area. And what they showed is that those early human settlers in that area actually kind of accidentally built those mounds by sowing seeds that they'd collected, and ended up building these like little like permaculture havens throughout the Amazon basin in a very kind of sustainable way, which I was totally reminded by that previous educator that student was. So that project was really homes back to those early roots of agriculture 10,000 years ago, and originating in South America, and also with echoes back to the great Aztec Empire and the invention of hydroponics. And now moving forwards into outer space, when we go, it's quite likely that hydroponics are going to be one of those reliable things that we need to colonize these extraterrestrial environments. So we can trace it all back to those early roots. Thank you.
That's fantastic. I love the fact that you're always bringing history to the table here. Last week it was the Romans and salting the fields, and now it's the Aztecs and these islands of nutrients, very similar to the biopatch. So
yeah, that's chinampas. You know, I was talking I don't know, a couple of years ago about the chinampas. That's the way our Aztecs used to crop their fields. As Dr. Baker said, it was like an island with mud from the area and stuff, and they have nutrients from fish and salamanders that are actually native from that specific place. So that's something that, you know, that's kind of my research. I'm doing research into like toothpaste to see what happens if a plant can grow in toothpaste, because it might help with the health of the seed, because it has like fluoride and stuff, but I don't know how the concentration. And the other was to try to build like a chinampa, but in a test tube. So I'm trying to get probably some mud out of the aquarium nearby, and probably we can test that in a test tube. So with some layers of clay and other stuff, that's part of the plan that I'm working on.
Very exciting. I love this. So let's keep investigating here. We're toward the top of the hour, so we're going to wrap it up. One thing, we launched this balloon at 9 o'clock. Where is it? Well, it's doing a lot better than our balloon last week. Our balloon last week was quite dismal. It went probably the shortest distance of any of our long distance balloons, but this one looks like it's moving along here today. You can track it on this website. It should be aloft for a number of days. It might last as long as a week or more. This one right here is about 25,000 feet. I guess I should probably put this in meters. Oops. And it's traveling along at about 55 miles an hour. You can see it's traveling now through, it's getting into the Central Valley here, just getting into the Central Valley. By tonight, I'm going to guess it's going to be probably over this way here, still in California. It looks a little bit like a slow path. Our NOAA model that I ran yesterday, I'll need to run a new model here, shows us overnight here traveling over Arizona into Mexico. So it's heading out your way. And by same time tomorrow, we should just be in northern Mexico. And by the end of the third day, we'll be getting toward the Gulf of Mexico if this model holds. The weather looks clear. You can see the rain is very minimal here. There's a couple spots here, day 3, 4, and maybe 5 or 6. We'll see it again. But it's heading out over the Atlantic there on its way to, I don't know, Africa, Mediterranean, Europe. We'll have to run the model. But we were a little disappointed last week where it didn't get very far at all. So no guarantees we're going to get much further, but I think this is a pretty good flight. This is all in preparation for the Lodi Unified School District is going to launch one of these balloons with a different balloon type, probably in about 3 or 4 weeks, and we're going to attempt a circumnavigation around the planet. So a complete journey around the world, and I think it'll take less than 80 days. It'll be kind of nice. So looking forward to that. But I just thought I'd share that as an end cap to our adventure with everyone today. Thank you for joining us. Javier, thank you for you and Monterey Tech. Your presentation is wonderful. I invite you guys to come back, share some more of your experience and knowledge. If you're doing some research with any of these legumes, we'd love to see how you're developing it. Dr. Barker, thanks again for joining us. Our teachers that are online here inside Zoom and those that joined us in YouTube, thank you for attending. Parents, if you brought your students in here, thank you so much. Students that are engaged and active, you know, keep that light lit. We're here to keep you inspired and passionate about the things that you love, whether it's physics, whether it's biology, whether it's chemistry, any of the life sciences, history. We're always able to find a way to draw history into our story, our narrative. So look for this again next week. We'll love to join you. And if you haven't reached out to us directly yet, send a note, hello@Magnitude.io. We'd love to hear from you, and maybe you can be here behind the velvet rope here backstage with us in Zoom as we talk to the rest of the world. So until then, have a wonderful afternoon or evening or early morning, depending where you are. Have a wonderful weekend, and we're going to catch up with you all soon, okay?
Thank you.
Take care.
Thank you.
Bye.
Thank you.
Thank you. Bye.
Gracias, chicos.
Adios.
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 Yes.